All right, we are live. Welcome everyone to the seventh release party. And today, sorry for being some minutes late. We are two Spaniards here, and we are usually a bit
On
on
time.
time, right? No, but we are super excited because we are on the seventh release party. And if you've never been on a Balena release party, this is like a live stream where we are going to release a feature live here with you. And today it's time to release a feature on balenaOS. This is why I bring my balenaOS t-shirt. And for this reason, we have here Alex and Michal that I'm going to introduce in a second. Ready to go. This release party is about secure boot of balenaOS and full disk encryption on Intel or x86 generic devices with TPM, with secure elements that we are going to cover at some point. So first of all, let's do introductions. So Alex, how are you today?
Hello, I'm fine, thank you. My name is Alex, and I've been working at Balena for over 2 years now. I'm part of the OS team, so that means that I work with Balena OS, just making sure it works well, it's robust, lightweight, and it runs containers as best as possible, really.
Is this your first release party?
I've appeared in a few others, but it's a fun one. The first one that focuses on the OS. So yeah, it's the first one where the OS team is like the main character. So yeah, probably we could say it's the first one.
Awesome. Michal, how are you doing today? I see a lot of teas next to you. Or
Yes,
this is beer?
it's a tea and water. It's tea and water. I'm doing good, thank you. So
feel free to introduce yourself. Yeah.
My name is Michal. I'm also on the Balena OS team, so my duties are similar to Alex's. And on top of that, Secure Boot and full disk encryption has been one of my focuses over the last few months, or maybe last year. So this party should be the final stage where we actually put it all together and release it so that it's available to people. So really looking forward to it.
That's awesome.
Very exciting. I hope that tea is enough for one release. And you don't need another refill, but yeah.
Yeah, we are going to talk about that in a second, what is needed. But first of all, Ayan, feel free to introduce yourself. Welcome to Balena.
Hi folks, hi everyone, I'm Ayan. I'm developer advocate here at Balena, and currently I'm going through my residency program. That means I'm going to be making a project which I'll share with you pretty soon. So yeah.
I didn't introduce myself, but I'm Mark. I'm as well developer advocate based in Europe. So we have India developer advocate, Europe developer advocate. At some point when David will wake up,
the US developer advocate is still in sleep.
We will cover. So let's introduce maybe first what's secure boot and full disk encryption. Who would like to talk about that?
So I think I'll take the opportunity. So secure boot and full disk encryption are two separate features. We want them together to achieve a common goal. So the current situation with Balena OS is that for flashing Intel devices, we always advise to disable secure boot because we do not support it at all. And in fact, if it's turned on, Balena OS won't boot, which is okay for most people, but we have users that are interested in more security features, especially full disk encryption. And to start with Secure Boot is basically authenticating the operating system that is allowed to boot on your hardware. So it is possible to set up your, at this point, Intel hardware to only boot certain operating systems. And if you configure it correctly, it would refuse to boot anything else. And we need this to ensure that our Balena OS images are not tampered with, because we do for like disk encryption, we want to do this completely automatically. Most like major Linux distributions, they will just prompt you for password, but that's not an option for us. So to ensure like we can do it securely and automatically at the same point, we need to make sure that the OS has not been tampered with, and that's what Secure Boot helps us with. For full disk encryption, this incorporates basically having a passphrase stored somewhere securely in the device. And that has a hardware requirement. So again, on Intel boards, this is handled by TPM chips. And so if the device has a TPM chip and it's usable to us, we can use it to start a passphrase and use the TPM to unlock it only if Secure Boot is enabled, the system has not been tampered with. So when the attacker comes and takes possession of the hardware, even if they like pull out the hard drive, or even if they try to boot some of their custom operating systems, they would not be able to take control of the data that is stored in the device. So this might include both user applications. There are users who are very interested in protection of their intellectual property. So even if they ship a device to their customers, they want their software protected. Another use case is that we have users who need to store plain text passwords on the device, so they although do not want these to be easily extractable from the hard drive, and this feature should help us with both.
Oh yeah, that's amazing. But we have our first question coming in. I don't know if you would like to answer that. So Anuj is asking, are
That's a
TPM
very good
chips
question.
impacted by the semiconductor shortage? So Mikhail, you want to
It's a
talk
very good
a bit more
question.
about TPM chips? Yeah.
It's a very good question. I have no idea whether they're impacted. They probably are, since everything is.
Not sure. This is a memory, right? Or
No, it's a chip.
it's a chip?
Piece of silicon that has
It's a secure element. Yeah, secure element chip.
Okay. I thought it had like some memory.
So it's the TPM 2.0 chip that we're referring to and we're targeting for this feature is a requirement for Windows certification. So any Windows certified hardware just has to have it on the motherboard. And yeah, that's all I can say.
Okay.
Go ahead.
Go ahead. Sorry.
No, I was about to ask whether you want to dive deeper into the TPM or whether we do it later. But
no, maybe we can cover TPMs later, right? And
yes.
we will open as well the topic of TPMs on ARM architectures, right? Maybe.
Okay.
Look, I know she's having really good questions, so maybe we can cover that. So it's a TPM that we are going to use the same necessary for Windows 11?
Yes. So up to Windows 10, I think even the older versions were acceptable. They're no longer acceptable for Windows 11. So,
cool, yeah. So we are getting, we are going to take the benefit that Microsoft, right, is using that on these x86 machines. Actually, sorry.
Yeah, I was going to say we should mention that we are only supporting TPM 2.0. We don't support all the versions in this implementation.
Because at some point I wanted to show my Intel device that I have at home, but this has a TPM 1.2. So at some point we can cover this. Meanwhile, the Jenkins is compiling everything, right?
We'll have a lot of time.
Should we cover like the milestones of this release party? What do you think?
Oh yeah, that's a good idea.
Let's go for it.
So I prepared these graphics. Maybe we will improve. We will iterate that during the release party. But we have different stages. I don't know if Alex, Michal, you want to talk about them and the order of them, or not order at all?
Yeah, maybe. I mean, we will probably do them in the order you have them there. So we have a series of PRs into Balena, which is the Yocto layer where we keep the common paths of the OS. So we'll probably briefly review the PRs and explain the working functionality via the code. Those PRs have to be approved. We did a first pass yesterday, but it's probably worth to go through them at least and explain what each individual PR is doing. We'll approve those. They will run a series of tests in our automated testing, and then they will be merged. So that then has to be spread into a device repository. In this project, we are going to pull these changes into the generic x86-64 device type. So we'll need a pull request into that repository to update to the Balena version that contains those changes. Again, that's going to pass some series of tests, and then it will be merged. And once that passes, we'll be able to deploy that release into staging and do some further testing. We'll probably have some manual testing to do. As part of this release party, we want to work into automating the tests, but we haven't gone there yet. We don't have them. So hopefully some people will join and we'll all together work into this automation. So
Alex, what do we use? Sorry for interrupting you. But what do we use to automate testing of Balena OS?
So we have a couple of projects. We have what we call we have a rig of different device types, testbot, which is based in London, and we have a framework which is a Leviathan, which is like the test harness where we implement the changes. So what we've done is we've separated the test harness from the test suites. So we have a folder in Balena that contains all the different test suites. And typically what we do, especially for simpler changes, is when we commit a PR to Balena, the same commit will contain the test that's going to run. Okay. So when that PR is merged, the CI system will actually run the test. In this case, because the feature is quite complex, what we have is we've implemented the PRs for the feature, we've written down the manual testing for the test, and then we still have to go through a process of reviewing those manual tests and thinking about how we're going to automate them and integrate them into Leviathan.
That's super interesting. Yeah, looking forward to know more about these two projects.
Yeah, so the future, we hopefully want to get to a point where we don't have any test that needs to be run manually. So the ideal situation would be we introduce a change in Balena, and once that PR is tested and merged, it just gets automatically PR'd into the different device repositories, which also gets merged, and then there's an automatic deployment into production. We haven't yet got there. We are close for some of our device types like the Raspberry Pis, but we are still working on finishing the automation so that we have the same level of coverage in our automated test than we have when we do manual testing.
Mm-hmm. And then this will be released and tested on staging?
First, yes. So that is part of what I'm saying, because we don't have the complete set of tests in the automation. We usually need a manual test. So what we do is we deploy to staging first. We run the tests that we are missing, and then we deploy to production. Hopefully, in the near future, we won't need that, and we'll have enough coverage in our automation to be able to deploy to production directly.
Okay, yeah. And then, sorry, go ahead.
I think that sounds good, like a good plan for today. But yeah, well, is it something that we are looking forward to, like releasing it right away to the public, or is it like there would be some more testing involved internally, and then people can, customers can use it?
Depends where we get. If everything goes really smoothly, we will release it to production, and it will be ready for customers to use. We'll see. We'll have to review the changes, merge the PRs, and we have to run through the manual testing, and then depending on whether we find issues and what type of issues we find, we'll decide whether it's ready for production or not.
But yeah, nevertheless, this is coming real soon.
Hopefully.
Bug free, I hope. Okay, so let's start work. So when we are gonna show progress with different colors. So at the moment, everything. So if something is on red, it's because we still haven't done anything. But yeah, if it's on working progress, we're gonna put it on yellow or orange. Not sure yet. I need to check the colors. And when it's done, we will move it to green, if that makes sense to you.
Yeah, sounds good.
So
Yeah.
let's start working. Makes sense.
Just to make it a bit clear for myself and so for some people out there. So what we are trying to achieve here is with Secure Boot, we are ensuring that only the images for our operating system that is actually coming from our customers or vendors, that should be the one that is flashable, and not by let's say some notorious hacker out there. So that does includes the bootloader, I believe the kernel and the root file system. But also, given the fact that the device lives on the edge, it could be in the wild west, and even if the device compromised, then the full disk encryption ensures that no data would be compromised and it's still in a very secure form. So given the amount of hacks that includes the IoT devices today, I think it's gonna be a great feature. But did I get everything right in order?
Yeah, it might be worth to speak about keys, Michal, because we don't want to give the impression that it's customers who are actually going to sign their software.
Yes. So there's signing happening at multiple levels. So I'll briefly cover that. The first level is signing for Secure Boot. So Secure Boot only verifies the first thing that the firmware actually loads, which in our case is grub bootloader. So we build it as an EFI application. We sign it, and we configure it so that it verifies the next steps. So how that works is that we embed. So one step back. So what does Secure Boot verify against? That's a set of keys that we provide for the users to program into their firmware. There's, in general, two ways of doing it. Either the firmware will allow you to load them from a USB drive or something like that. Basically, you enter the setup program on your device. There's going to be fields like load the keys. The other thing is it may let you just reset the keys or remove all of them, which means after reboot, the storage is programmable. So balenaOS would automatically detect that it is in the setup mode and write the keys on the subsequent boot. And that's how these are programmed.
So for the first case, the customer will have to find the keys, and what we're planning to do is to package those keys with the images itself. So
Yes.
the keys will be included on the boot partition of the images.
Exactly.
Now, because this device type has a flashy image type, they might have to unwrap the flashy image until they get to the actual image and then unpack it to get the keys out. We might find a better way of doing that, but at this moment in time, that's how we are thinking about doing it. The second mechanism where the customer, they only have to get into the BIOS, configure the secure boot mode, and then the system will deal with everything. That's still to be implemented. It's not part of this release party. We will plan to do it soon, but we haven't yet implemented that part.
So we know how to do it. We just did not implement it yet.
Oh yeah, that makes sense. But everything we are doing today, that is targeted toward the, I think, x86 architecture. So Intel Nuke boards and every Balena supported board that runs on x86 architecture. So that will be supported
and has the necessary hardware.
As the necessary
TPM
hardware,
2.0,
TPM
yeah.
2.0.
The TPM and boots in UEFI mode.
Oh, all right. And would you like to just talk about a bit why we are not doing it for ARM just yet?
So that's a longer discussion, but we can dive into that later when we
Sure.
have.
Yeah, sounds
But I
good.
think we can say that you cannot speak of ARM as you can of Intel. You know, each ARM device has a different way of doing it. Basically.
The short answer is that the TPMs on Intel hardware are pretty much standard. Like they all behave the same from the point of the operating system. On ARM, the ecosystem is much wider and much less standardized. So if I took it to the extreme, like every device may need its own approach. And there are devices that just do not have the hardware, so it's not 100% possible to use the feature with them. But yeah, that's a brief overview.
Yeah, that makes sense. All right, I think we can start working and make it
Absolutely.
happen.
So you are gonna start to update Balena?
Yeah, I think we're gonna go through the PRs and
Okay.
have them approved. And
We have
see
yeah.
how fast we can merge them.
Let me show meanwhile some comments from Arijit. Good to see you, Arijit. Long time we don't talk. Any updates about Fin 2.0 containing the compute module 4? I mean, I think the release party is not about this, but maybe we can try to invite someone from the Fin team here. Maybe Anush wants to join us and talk about that, even if this is a complete off topic, who knows? But this is why we do release parties as well. We like to leak our culture and show how we work. We are a complete remote company, as you can see in our flags. Well, maybe not here right now, but yeah, this is why we do release party, to show how Balena works. Maybe you are an operating system hacker and you would like to join like a full remote company and work with people like Alex or Michal. Or you're a developer advocate and you want to work with Ayan, David, and me. So we want to show how we work, so you can get excited to be part of Balena. So maybe if someone from the Fin team is watching this and wants to join for some minutes to talk about the Fin situation, that you are welcome.
Okay, I guess let's do some work in the open.
Sure.
So
you want to share your screen, Michal?
I want to share my screen, exactly.
Okay, let me share your screen.
So this is the Meta Balena repo we were referring to. As you can see, there's quite a bunch of PRs
Let me
open.
share it here as well for everyone.
I can probably make it bigger, right?
Yeah, please.
So that should be good. So there's quite a bunch of PRs ready, and I'll just go through the ones that are related to this feature, and we can go through them together with Alex and give some feedback.
So yeah, we were speaking about using a virtual device to test the changes in Meta Balena. So how it currently works is each PR is running on the rig. So it runs on Raspberry Pis and several others. We've been speaking for a while that we actually want to change that, because what happens is that we have a very slow progress in merging PRs from Meta Balena. So we've been, as part of this release party, we've also been working on some PRs to add like a virtual device, QEMU, so that we can actually just run all the testing on this virtual device, and hopefully that will make it quicker. So yesterday night, I know there were a bunch of PRs that had to do with that effort. I don't know if they've been merged already or not.
They haven't.
They haven't. So yeah, because we said that we also wanted to remove the Raspberry Pis because they don't apply to this feature. So it doesn't make much sense to test every PR on Raspberry Pis. But if we do that, we don't have a device to run tests on. So until we have the virtual device, maybe I wouldn't remove them all. Michal, I don't know what you think about that. We can probably leave the Raspberry Pi 4, which is quick enough.
Okay, we can try. I think, like, for the sake of the party, we might need to bulk some of the PRs together then, to not to have that many rounds of builds, but I think many of them are simple enough. So
let's see how it goes.
Yeah. Okay. So I'll start with the first PR. So this one adds an out of tree module that some of our users are interested in. Before they were just building it in a container, but when this feature, when Secure Boot is in place, the kernel actually authenticates all modules it loads to prevent loading of malicious modules. So it is no longer possible to build the kernel module in your container without having it signed by Balena. We're still discussing how to make this better, because we obviously cannot have all source code for all the modules out there, and there's probably users who do not want to share their code. But this one module is open source, so we just decided to start with it, try to ship it, and try to sign it as a part of our build process and see whether that works.
Yeah, I mean, we'll need a mechanism to build out-of-tree modules in containers as we do now, with the ability to sign them. And as soon as we have that, then we'll remove whatever out-of-tree module we've added to the main OS. It's something we really don't want to do, but at this point in time, if we want to release a feature for these customers, we don't have any other option.
Yeah, so to summarize this, it's not the definitive solution, it's the one that works right now, and we have ideas how to improve that and make the self-building work again. So what this PR does, it really only downloads the archive with the module, then builds it. The module itself can build in two flavors. So it copies the sources and builds each flavor, and then it installs it into the OS. And then it calls a signing service that we have running. It takes the modules, asks the service to sign them, and gets them back together with the signature.
So yesterday, when we were reviewing these PRs, we mentioned we wanted to change the way that we were calling out to the signing server, because we are doing the same type of thing from several places. We spoke about having a recipe with the keys. So we package the keys on a package, and because the keys have to finish in the boot partition. So that recipe can then install the keys maybe in the sysroot, and then these recipes, they no longer have to call out to a signing server every single time. They just have to use the keys that we've already fetched. So this recipe should depend on the one that packages the keys, and just use the keys that are available.
So I would change the statement a bit. So there's two places where we need to talk to the signing service. One of them is the actual signing, which we need to keep. When we were reviewing this yesterday, we were saying that we need to unify the calls into a library, so that we don't have, because this snippet, we're going to meet it multiple times today.
Yeah.
So to make it simpler, we should have a single call that just says sign.
Yeah, we'll have a class that does it. Yeah.
Exactly. So that's one of the use cases, and this still needs to call the signing service for each build. We have a different use case, which is publishing the public keys that the customers need to access. And these are the ones that should end up in the boot partition. And these are also queried from the service. And as Alex mentioned correctly, we want to package them so that random recipes would not need to pull them every time they need them. And we would just ship them with the OS and use them.
I understand. So it's not the signing happening in the computer that's building. The signing is happening on the server.
Signing is happening on the service.
You're sending a blob to the server and saying, sign me this, and then it sends you back a signed blob. Okay.
Exactly.
So the signing server that we are talking about will it be running in the Balena server farms?
Yes, it's a Balena app. It lives under balenaOS org. The repo might be private at this moment, but if you remind me later during the party, I might just turn it public. There's no reason for it to keep private. So yeah. just note it and remind it when we have nothing to talk about, and we can deal with that.
Yep, absolutely. Mark took a note.
Yeah,
Okay.
noted here.
So this is really all there is to this PR. It's a single recipe. That's how Yocto packages software, basically. The only extra steps are the signing.
Okay, so I think if we create an issue or we make a note that we want to clean this up a bit with a class,
okay, so
you can probably self-certify it and.
So I'll add an issue saying
Yeah, we just make it easy if it's centralized. Like if we change the signing mechanism at some point, we don't have to chase 20 different places.
so we have the issue so that we don't forget we want to do this. And other than
You
that,
can maybe do a cross-reference. So if you copy the issue and you add a comment, and then we just have it. We keep a record of the review. Yeah, so you might have to rebase that.
Yeah, so yeah, this cross-reference is back. That's good. So right now it tells me two things. It tells me I need an approving review and that the branch is not rebased. So let's deal with the rebase first. I could do that manually, but luckily we at Balena like to automate everything. So I can just ping our bot called Balena CI and ask it to rebase for me. So fingers crossed, when Balena CI notices the ping, the PR should get rebased automatically, which just happened, and the tests will get restarted. Yeah, so this is gonna take a while. I still need the approving review. So if we were doing this asynchronously, as we normally do, I would wait for somebody like Alex or somebody else from the OS team to give me feedback and review it. But since we discussed this live and I got the impression that Alex is okay with it, I can ask for a virtual review. And how it works is I again ping Balena CI and I tell it I self-certify. So what happens is with this comment, I say I am not waiting for a review from anybody else. I want it merged. And let's see again. Balena CI gave me the approving review. So that's it. Once all the tests pass, once the Jenkins build is finished and all the tests pass.
It might be worth to go a bit through the tests. So we have a bunch of like CI type of tests that have to do with the formatting of the commit logs and the versioning. And then you see that we have a test bot there. It's going to run tests on the Raspberry Pi 4. We used to have a lot more. but we thought that for the sake of speed in this release party, we wanted to at least have one. It was meant to be, as I mentioned before, a virtual QEMU device, but that work is not yet ready. So for the time being, it's still the Raspberry Pi 4, even though this specific feature doesn't apply to this platform. It will just run the standard test and make sure we haven't broken anything else.
Yes, so I can quickly go through the test since this is going to take a while. So I'll go from the bottom. Version bot generate version. So at Balena, we have automatic versioning for pretty much every project we have. Version bot is obviously the bot that handles that. And how it works is that in each of our commits, we have to specify whether it's a major change, minor change, or patch change. And based on that, version bot, well, in this check, first it will check that there's a tag present in the commit, which looks something like this. And second, it tries to generate a version. So this means my commit is okay, and it can be handled. So what else? Check versionist. I actually don't know what it does.
That's the one that actually creates the version.
Okay.
The
so
tagging.
this only checks for the tag, and this one.
The syntax, yeah.
Okay. Okay. So every day I learn something new. So yes, we've got some linting for README and license, obviously. Check commits. Again, don't know what this does.
Well, that's the
validate.
one that checks that we have a change type and that type of thing.
Okay, so what does this do then?
The one that generates the version, and then the second one is the one that actually tags.
Oh, I see. It adds a tag.
Yes.
Yeah. Okay. So that's it. So then we have the Jenkins build, and I don't think this is accessible from the outside world, so I'll just show that. We have a job that would spawn a thing we call Yocto all, which will try to build every device type we have with the new Balena version and see whether it passes. So this is why it takes a while. If the change is small, it's something like 30 minutes. If it's big, it might be longer, but we'll see how it goes and maybe do something to speed up eventually.
So we have a shared state cache. So these builds, they are actually building from cache, but depending on the type of change. So sometimes you have to compile or recompile quite a lot. So it might take longer. If nothing changes, if it's a very small change and you can build from cache, it will take around 3 or 4 minutes per board. But more complex changes take more time. And each one of those is actually a family. So for example, if you go into, is it a family or is it a board? The ones that appear here.
It's a board.
It's
like
a board
we've got Pi
okay.
1, Pi 2, Pi 3.
Yeah, okay.
The states cache is definitely savior in Yocto, but a lot also depends on the server configuration that we are using for building.
Yeah.
Yes. So a note on this PR.
We should say that our build servers are running balenaOS. So
yes, they are.
Good time to plug.
So we are building Yocto on balenaOS actually.
Yeah. So all the Jenkins workers and the Jenkins master, they are balenaOS applications, and probably not me, but somebody who oversees that can see it as a regular Balena application in Balena Cloud. Actually, I might see that, though I will test before publicly humiliating myself on the stream.
You can try. There's no shame.
Actually, if I'm not wrong, on Balena Hub, there is a developer from the community who submitted an application to run Jenkins on Balena as well.
Mm-hmm.
So where's my stream? Here it is. So if I do this, so these
Oh,
are the devices that are running our Jenkins. We have Jenkins master, and all the others are the workers. And you can see we all have them as Balena applications or Balena devices. That's how we manage them. So these are the workers that show up on the
okay. So this
here
is what you see here. It's the same than on Balena Cloud, right?
Yeah, we could cross-reference the UID. So 8537 BAA.
Okay.
Here it is. That's the one. But that's how we run Jenkins using balenaOS.
That's super cool. That's dog fooding, right?
Yes.
So when this will be accepted, what will be next step? So you have more PRs to?
Yeah, we can probably go to the next PR we have.
Mm-hmm.
How many you have to get accepted to update MetaBalena?
There were 5
like
yesterday,
9.
but probably they increased.
Oh my god!
So a note on this PR is that it doesn't. The only change it does, it adds the recipe. Nothing is pulling it yet. So the build should really go just from the cache. When we start pulling it into the generic device type, that's where it starts to actually compile all the things we define here. So that's where it's gonna get funny. So next one. Yes. So in our RAM disk that we bundle with balenaOS, we do a lot of stuff. One of them is that on first boot, because after the device is flashed, the image has some static size with the minimal size for the data partition. So one of the things we do on first boot is that we check whether there's enough space at the end of the drive and expand the data partition as much as we can. So when we introduce full disk encryption, this needs an extra step because how it works now, we need to resize the partition and we need to resize the file system that lies on top of it. With full disk encryption, there's one more layer because there's no file system on top of the raw partition. On top of the raw partition is an encrypted volume that we also need to resize, and this encrypted volume then hosts the file system. So this only adds the extra steps necessary to resize the encrypted volume as well.
Yeah, we reviewed this yesterday also, so there's not much to it.
Yes, so same as before, it tells me the branch is out of date, but I'm not gonna rebase it yet. It would trigger off a new Jenkins build, and after the previous PR is merged, it would still need to be rebased again. So for this one, I'm just gonna self-certify and rebase it once the previous one is done.
A question, Michal.
Go ahead.
Do you know if we have an automated test that makes sure that the data partition has been correctly expanded? I don't think we do.
I don't know. I don't think we do, but I don't know.
I think we might add that as a thing to work in the release party. I remember having issues on support where the data partition wasn't correctly expanded. I remember, for example, some customers that had a loss of power while they were flashing, and on the next boot, so no, they had a loss of power on the first boot, so the partition didn't get expanded correctly, and then on the consequent boots, it didn't retry.
Oh, I remember creating an issue for that.
There might be an issue,
we
or even
might
a
find
PR
it.
for it. Yeah.
I remember this. I've had this on support as well. And yes, so we can probably see it in here. So the snippet of code above, it resizes the partition, and below it resizes the file system. So if you get power loss in here, where this new code is, you would end up with the partition resized, but the file system on it not. And somewhere within the script, we only check whether the partition has been resized. So we never retry to resize the file system. And that's a good point. We should automate the test for that, and we should make it more robust and include it for this as well, because yes.
Yeah, I don't exactly know how we will catch the corner cases like the power losses and things, but it might be worth some brainstorming. Yeah, I mean, if we have an issue in an open PR, it might be better just to leave the test when that other PR is merged and not confuse things in this release party.
Mm-hmm. Yes, anyway, let's see how you're actually doing. Oh, we already have some device types finished. So that's encouraging. 10 minutes built from the cache. Not great, not terrible. Okay, let's do the next one. Or do you want to do something to this? Leave a cross-reference somewhere?
No, I think it's fine. I mean, if we have an open issue.
Yeah, right. So the next one, add recipes for TPM tools. So this thing brings the user space utilities that are necessary to control the TPM, both like program it and use it. So there's no there's nothing
upstream,
custom
yeah.
in this. It's just taken from upstream. So if you look at the commit message, this is the upstream. It's the same tools that that are in this PR. So I actually self-certified yesterday evening, and yeah, you can see it did not get merged yet, but
is it waiting only on the Raspberry Pi 4 test?
It is.
Should we go and check the job in Jenkins, see what happened with that? So if you open the Jenkins build, we'll get the build number, and then we can go to the Leviathan job for the Raspberry Pi 4 and match the Jenkins build.
So you have to guide me, or
so
you can share your screen
the build,
if you know.
No, it's fine. The build number is 934. You have it
Okay.
there. So now if you do a search for Leviathan - Raspberry Pi 4, I think it's, yeah. So if you enter here and you go in the left column, we should be able to find, yeah, if you do a click on those, it should tell you which build has triggered that job in particular. Started by.
It's like this is 1174, or no. It's started by upstream project.
Yeah, I think this job is actually it's a couple behind in the queue. It looks like there's this one that's running at the moment, and there's another one after it, and then it's your PR. You can, if you go back one on the page, yeah, if you go back to the list.
Where was I?
To
the list, this one.
Yeah, there you go. So if you look at the ones that are grey, they're the ones that are pending because we've only got a limited number of devices available right at the moment. And if you see, there's a little notepad icon next to it. If you put your mouse over that, it kind of gives you some of the information on what that build is for. So you can see that one there. It looks like it's part of the ESR one, and then the one above it, you can see the name of the PR, the branch tools. Even TPM tools. Yours. Yeah. So that's yours.
This one, and this is the one we rebased, the first in the party. No, it's yours.
Yeah. With that one though, I mean, yeah. So what you can do is if you want to be greedy, you can cancel pending ones before yours and shift yours off in the queue. But this is something that we want to that we're kind of limited with running tests on real hardware for everything, right? We can only have so many devices.
How is the virtual QEMU work going, Ryan? I know that you guys were working hard the last couple of days.
Yeah.
What's the status of that?
So this is one of the things that was in the queue for a while, and the release party kind of lit the fire underneath that to try and get it done in time, and it's gotten to the point where it runs some tests, but not all of them. So we can't just deploy it. I haven't figured out why those tests aren't working. The ones that, some of them I have fixes for, and that's what the 651 build here is, I guess. But yeah, not all of them.
Okay.
Yeah, it's just going to take a little longer, unfortunately. But then when it is done, the gains are big because we can just run all of these jobs, in parallel on virtual devices, and only test on hardware when we need to at the end.
So Mihal, I think we should cancel at least the job that's before yours, because they take like 1 hour to run.
The ESR.
Well,
because this one failed, it's the next one.
It just started. Okay, yeah, we are late then. Cancel it. Yeah, I mean, it doesn't matter if it started. I would cancel it.
Okay.
I don't know if did we ping the team to avoid rebases and stuff while we are at the release party. Maybe we should.
I haven't.
I will.
Okay. So let's see what happens.
I just aborted the one that had just started. It hadn't actually started, so I just aborted it. So now it's yours that's running.
Okay.
We have here Ryan, someone new on the stream. Feel free to introduce yourself.
Yeah, with all the bad lighting in the world.
Worries.
But yeah, so I guess the thing that I kind of work on is the test bot. Although we're kind of wanting to rename it to the automation kit now, because I'll kind of I guess if there's time I can kind of show it to you in its current form and explain what it does.
We're waiting for Jenkins to build, and we're waiting for test bot to test, so I think you have plenty of time.
Yeah. So I guess I can. How do I start this? So the Jenkins job that you were just showing, Leviathan Raspberry Pi 4. I guess I can explain what that's doing.
Do you want to share your screen to be in control, or?
No, it's okay. You can just leave that there. Yeah. So what's happening here is the scripts that are running it as part of this job. It's sending like the image that was just created from the Yocto build job. It's sending that to a test bot, and the test bot is connected to a device that we want to test. We call it a DUT, device under test. In this case, it's a Raspberry Pi 4, and the test bot's receiving that image, receiving the tests that go along with that PR as well, and it's then flashing the Raspberry Pi 4 it's connected to, and it's running the tests against it without anyone having to manually, do anything.
And if you click on the console output, Michal, we will see a list of the tests that it's running. You'll have to maybe scroll down a bit, but there's a summary printed.
This is the one that was Jenkins needs to be refreshed sometimes. Yeah, it's the one that I think we just closed.
Was aborted. So let's go here. Let's look for the running one from my PR.
Yeah, scroll little by little.
Yeah. So it's pretty crazy right now. It gets formatted at the end, right, in like a summary that's a bit more readable. But these are the tests that are running. There's 2 test suites running in parallel on 2 different test bots at the moment, which makes things a bit faster. It's still slow because when you're running stuff on real hardware, it could take a while sometimes. So that's the story. We send these kind of like draft images and tests to a test bot remotely, and that test bot flashes the device being tested and runs the test against it, and then reports back to this Jenkins job, which then reports back to the PR. That's the kind of flow. And the test bot itself, the automation kit, as I should probably call it now, it looks like this. So it's basically a fin.
Let me stop sharing my screen and bring you.
Yeah. No worries.
Oh, yeah.
I can do it.
Here we go. Big me. Yeah. So the way it is at the moment is basically a fin, which you can see at the bottom there, with some extra stuff attached to it. It hasn't got that many special powers. It has all the capabilities of a fin, plus a few extra things that the fin can't do by itself. And it takes the form of this hat, which is like the kind of base hat that plugs into the fin's GPIO header and the coprocessor header. And it also takes the USB header that's exposed on the fin as well. And that's the base board. And it's connected to what it can do is it can control the power to a device under test through this little board at the top. So it can control the output voltage and it can toggle the power on and off, which we need to do to flash things remotely. And it can also kind of flash an SD card and toggle it remotely as well using this little attachment here. It's called an SD mux. So that's this little board here. So there's the fin. It goes in the top there, and this goes into the SD card slot of, say, a Raspberry Pi, like this, just where the SD card would go. Yeah, there it is. And what it does is it lets you connect the SD card inside it to the fin, and you flash that SD card, and then you can toggle this little board here, so the SD card then is connected to the device under test. So it kind of automates that whole process of, flashing an SD card with Etcher, taking it out of your laptop, and then putting it into the fin. So yeah, that's basically all, the special powers that it has. Everything else that we do with it is a capability of the fin. So we also create a network access point for the device under test to connect to the internet through. That the fin can do that. We can capture serial. We can capture HDMI, all using just the fin. Yeah, so that's what a test bot looks like at the moment. And then the way we kind of manage the test bots that we have deployed is actually just through a Balena application. One of the good things is we can use our own product to manage our testing fleet and deploy updates to it, and expose them remotely to these Jenkins servers. So we don't have to do a whole lot of work, to kind of monitor what resources we have available, because Balena Cloud does it for us. If that made any sense, that's the test bot.
That's super
Yeah,
cool
it sure does.
introduction
Yeah,
to that's what.
absolutely.
Yeah, I can show you actually. I'll share my screen a little bit. Actually, I'll show you
Sure.
the So I'll just press share here, right? Share
Go ahead.
screen. So if we go to the dashboard, so we've got this testbot rig, right? These are all, this is Balena app with a bunch of test bots in it. And what the Jenkins jobs do is they look for a test bot in this fleet that is connected to the device type that the Jenkins job is building and testing for. So, for example, this is for Raspberry Pi 4, the one that's running at the moment. So as the test starts, it looks for idle test bots that aren't doing anything that have a Raspberry Pi 4 attached, and then it can talk to it just using the public device URL of that test bot. What you can do is you can in theory add more devices into this fleet to kind of run your tests kind of in parallel. But yeah, that's still something that needs to be improved. But we're doing it at the moment, running two like big test suites in parallel. There.
Oh.
So you can see this thing here. See what the test bot is doing. It kind of sets up a Wi-Fi access point for the device under test. You can even you can also get into the device under test through this test bot if you just SSH through it. Actually, let's see if that works.
Can you maximize the terminals?
Yeah. So actually, what's this? So if in the Jenkins logs, you can see what test bot the test suite's running on. So this one is AF82. AF82. It's this guy here, 90 chair 6. So you can just use a CLI in here, I think, to see all of the. It's probably this guy here because it's this kind of unreleased balenaOS version. So unless it's in the middle of a reboot or something, we should be able to just. Okay, it's probably doing something else right now, but yeah. So that's that. That's how that works. Usually that console logging stuff, is kind of crazy because it's the logs of two test suites coming out at the same time. But usually, if everything's gone well, you can just look at the end at like a JSON summary of what the tests got ran and if they passed or got skipped for whatever reason. You can get the another cool thing is we capture the serial the HDMI output for some of the tests. So we kind of like capture the artifacts and make it available here, so you can come and have a look at what was going on during there. Nothing there. But yeah. Yeah, so that's I don't know if there's anything else to show. Yeah, I think that's probably it.
Super informative, super interesting, Ryan. Thank you. I think Rafael as well mentioned that he just joined now to watch to see the test bot, how the test bot works.
It's quite cool, and as it stands at the moment, it's quite it can control quite a few types of device. There's a few improvements that are in progress to make it more generalized, so you can control devices with a bit higher voltage requirements, and even devices that have like an AC input, because at the moment we can only provide like up to around 13 volts DC out of this thing. So beefier NUCs, Jetsons needed an improvement. And then another thing we're kind of trying to do is taking away the dependency on the fin, because there's no reason actually why it can't be used. The test bot can't be made out of like a Raspberry Pi 4, which just makes it easier to source more of them at the moment because of the compute module shortage and stuff.
Yeah. I think this is a recurrent topic, right? When you are talking about hardware, if the chip shortage is affecting these, and the answer is yes, it's affecting everywhere, even on the test bot, right?
Yeah. And the other thing we obviously want to do is just be able to. We have a rig of 10 devices or something running in the London office, but we obviously want more than that. But it needs to be scaled properly and not just ad hoc, kind of hackily adding more devices to the thing. If we actually want to keep it under control, so one thing we're working on is trying to create both a rig and a process to go along with it, so that it has some clear interface or kind of like API for, say, Alex G here to make a request to add something to the rig, and then there's that's as streamlined as possible to get it in for him.
Very cool. Let's get back into the update Balena. How is it going? What's the situation?
So we've got two things pending. One of them is the Leviathan for this PR that I've hacked in the morning, or rebased in the morning, and that's just running. That's the one job that we were showing.
While this is building, I have a question for Mikhail and Alex, maybe. So what we are trying to build is actually a sort of application that will talk to the signing server to get things signed. Did I get it right?
So that's the long-term goal. At this point, what we're building is so we have updated Balena, which is the common operating system base for all the devices we have. So what this build does, it makes sure that we have not broken any of the devices. That's what this Yocto job does. So this one goes a bit further. After it's built for, the Pi 4 64. So when this job finished, it's very likely that Leviathan kicked off a new task that's gonna appear here for the new PR. Yes, it's pending. So yes, that's Ryan's, and this is the peak driver that I've built. And so in order not to do like if it builds ship it, that's where the testbot comes in, and testbot actually tries to take the newly built image and tries to run it on actual hardware. In this particular case, it's Pi 4. So it makes sure it actually boots, it runs Balena engine, it's able to, start containers and do some like very basic or not necessarily very basic, but do some sanity checking that we want to do. And that's it. So when it comes to what you mentioned, the framework for talking to the signing service, that's a long-term goal. Where this would happen now is during the build, when we build some of the recipes. One of the steps would be, we we fetch the software from upstream, we configure it, we build it, then we ship it into the balenaOS image. And somewhere on the way, like after compiling, before shipping it to the image, we add the signatures. So at this point, it's a shell script embedded in the recipe. So what we want to do is extract this into a library that we would just call within the recipe. Because up to this point, as far as the party is concerned, we only saw the signing process once, but we're going to meet it in the other PRs, and you're going to see it makes sense to like factor it out.
Absolutely. Makes sense. And yeah, just another caution, you can totally ignore that if that doesn't make sense. But I know you mentioned taking the code for the server, the signing server public by the end of the stream, but just to understand what's running on the signing server that will sign the different things, is it something around OpenSSL?
Yes, so we need two kinds of keys. We need X509 certificates for Secure Boot and for the kernel to authenticate modules. And we need GPG keys for grep to authenticate whatever it loads, because that's what grep needs. And so the signing server is basically an HTTP API that wraps OpenSSL, GPG, and some tools for like secure boot signing. And there's not much magic to it. It just takes the binary that you send to it, runs the appropriate signing procedure, and gets you the result, either a detached signature or the binary with the signature embedded in it.
Yeah, great.
Let me do something off topic. We have a comment on the YouTube chat. Anyone who has a question, feel free to ask it on the chat. Yeah. So Julian is asking why we are not using plugins on. Actually, at Balena we use Flowdoc to see all these Jenkins and all these testbot results. What do you think?
Well, we run tests on every single PR, so our Flowdoc channels will be spammed probably if we had all that feedback. I mean, usually it's the owner of the PR that is interested. So if you know that you want to get something merged, you just check, and usually the test should pass, and that's it. It's only on the rare cases where it fails that you actually have to go and read them. Whether it's easier to do it on a Slack channel where you have all the test results for all the PRs that are not yours, or just go and fetch yours. We just like to do it this way. I don't know if it could help to have all the results like in Flowdoc. I think there would be a lot of information, to be honest.
That's okay. So there are different ways, right, to have this user experience. But yeah, all right. So this is done, or this was not the.
So no.
No?
So the Jenkins job has finished. So if I go back to the original PR that we reviewed first, where it is. Come on.
So this one.
It's the driver.
Yeah.
So you can see Jenkins build is finished, and now we wait for the testbot job, because as soon as Jenkins built the Pi4 image, it kickstarted the Pi4 Leviathan job that I was showing somewhere around. And yes, here, this is the one. You can see it has Balena branch, the peak driver. So yes, this is, we just need to wait for this, because you see, this is the one for the TPM tooling. This is Ryan's one to fix QEMU, and this is the one for the original PR, for the driver PR. So yeah, that's why we want to automate this, because as you can see, it takes ages to run the tests if you're in a rush. So
should we move and review some other PRs?
yes, sure.
Yeah, let's do that.
Okay. So this one, as a part of the Secure Boot feature and Disk Encryption feature, we realized that we have an issue with our partition layout, and that is that for our current devices, we use the boot partition for holding the bootloader and for holding some like balenaOS metadata. And so while it does not matter for unencrypted devices, when we were investigating what to encrypt and what not to encrypt because it must stay encrypted for BIOS to read, we realized that we need the bootloader encrypted on the boot partition. But at the same time, we need the Balena config JSON and some other metadata encrypted because if an attacker would take control of these files and could extract them unencrypted from the device, they could gain access to the application. So as a part of this feature, we have designed a change that splits the boot partition into two. It's similar to what like major Linux distributions do. They have the EFI partition for only the EFI application, and then they have the boot partition that holds kernels in from disks, and that's not our case, but to simplify that, it's analogical. So as a part of our operating system, we have some services that mount all the partitions under /mnt because of how balenaOS works, and we can dive into that later, I guess. So we need a service that, besides mounting like mnt boot and mnt data and mnt state, would also mount the EFI partition, because when updating the operating system, we would need to update the bootloader that lies in it. So we would need it mounted. And I think the only thing we said about this when we were talking about it is that we should probably change it to like auto mounter, because we only need it during the updates, and we already do a similar thing for the inactive partition. So
Yeah, but we can do it on a different PR. It doesn't need to hold the merge. It's not significant enough.
Mm-hmm. So I've touched the A/B split, so I'll just elaborate that on that a bit. So we have the atomic updates feature in balenaOS, where we have at any time 2 copies of the operating system. So when you apply a major update, we keep the previous version just in case the new one would not boot or would be faulty. And we have mechanisms to check that and roll back automatically. So yeah, that's
I do have one more comment here. So if you remember yesterday, when we were speaking about the introduction of a new partition, I was arguing that maybe we should have discussed to introduce a new partition for all boards, so that we could also have some content just encrypted. I'm thinking now that maybe we should have not only one EFI partition, but we have a dual EFI partition, so that when we update, we also have dual update. So you can
like EFI A,
boot
EFI
from one or the other. Yes, I don't know if that was part of the discussion, but it would probably help. So if we assume that we can boot from any of them, it will give a more robust update process.
That's true. So I have one comment on that. And I think as far as Intel boards go, we would need to check whether this is actually possible, whether you can have 2 EFI partitions. I remember very vaguely that a few years ago, somebody was investigating that. And during the update, it was necessary to change some magic number in the partition headers. to actually flip them like A/B. So it was possible to have them, but only one of them had to appear as the actual EFI partition to BIOS.
Yeah.
But it seems doable with some extra work. So it's something we should consider.
Mm-hmm.
What
Yeah, so
other
let's go.
I'm sorry.
now I was going to say that in general, when we speak about partition changes, it's not something we can introduce like on an OS update. We would have to wait to a major update like a 3.0 release.
Exactly.
So that's the point where we would actually rethink. So this is something in between. So it's something that doesn't change the partition format. It just recreates the partition on the fly just for this device type when Secure Boot is on. I'm not extremely happy about how it's happening, but unless we want to delay it until we actually have a 3.0 release and a major discussion about how we want the future partition table to look like, there's no other way.
Yeah, agreed.
And is this PR accepted, or what's the situation of this?
Yes, I think unless there's any comments from Alex, I'm gonna just hack it.
Yeah. Second thing I'm thinking is, how does this tie with the Balena bootloader story? So in the case of x86, when we have a Balena bootloader, is that something that would actually go so is this EFI partition going to contain this bootloader? Are we going to merge?
So
it is going to be a UEFI application.
I'll give you an answer, but I think for the sake of the party, can you brief us on the Balena bootloader a bit?
Yeah, so we've been having a project for a while where we've identified that one of the friction that customers find when introducing a new device type to balenaOS is that they have to perform some customizations on the bootloader, be it Gboot or be it grab. So we try to do that easy. So we do have a class in MetaBalena that does some common changes, but still every device type is a bit different, and they finish up having to change the bootloader, which is not very easy. So what we've been planning to do is to come with a Balena bootloader, which is common for all platforms. And this is just going to be a Linux kernel, basically, that then is going to ksec into the real kernel for the system. So this is going to be a very small kernel that contains all the logic that we now have to customize on the vendor bootloaders. The idea is that we will use the vendor bootloader as it comes from the BSP, so Gboot or grab, we would not modify it, because the only job of this vendor bootloader is to boot the Balena bootloader. And then, because this is Linux and it is much more flexible and it's something we control, our customers would not have to modify that. So we reduce the friction of introducing a new device type to Balena. So I was just trying to find out how this new EFI partition fits in that story. So for x86 UEFI, probably the Balena bootloader would be a UEFI application.
Exactly. You can build the kernel as the UEFI application, keep it in the unencrypted partition, and just have it verified by Secure Boot. So to make sure nobody tampers with it.
Mm-hmm. Yeah.
We're gonna touch on it later because we have a poor man's implementation of this as a part of this feature. But yes, more on that in subsequent PRs.
Mm-hmm.
What other PRs are there available, Michal?
So what about this one? Do we?
Yeah, it looks fine. Let's self-certify it.
Okay. We need the exclamation mark at the end. I always add it, but I'm not sure it's necessary. Okay.
It is needed. You need to
It
finish
is?
an exclamation mark. Yeah.
Yeah, that's good.
Rafael is mentioning that at this point, you know the content of every PR just looking at the number. Is that correct? Or
It's not actually. It's I've been developing it for the particular device type for the generic x86-64, but I've only recently started pulling it out and adding it to Balena because we always knew we want this for everybody. It was like easier to develop with a particular device type, but I've split the PRs. It was on one very long PR, and I've split it into the bits, and some of them can be like generic for everybody. Some of them need to stay with the device, and yes. But
So I have a question for you, Michal. When you finish,
go ahead.
sorry.
No, I was just about to say that. I know the contents of every PR. I can comment on them, but I don't know it off the top of my head, like how they are partitioned in this particular repo.
I was going to ask, if we have a customer and they are designing their own hardware, let's say, and they are not using x86, but they do have the ability to place a TPM 2.0 on their hardware. Is this feature working in that case for them?
I don't see a reason why it wouldn't. It sure would need testing, but if it has the API of the TPM and the like TPM tools command line. Yeah.
So how linked are we with the BIOS? So let's say that it's maybe an ARM device. We have no BIOS, but we do have a TPM 2.0.
So we basically check two things. We check that we are booted in EFI mode. Not necessarily that we're running BIOS. We check that we can mount the EFI vars file system from the kernel. So I believe that's possible with some beta firmware on a Raspberry Pi as well. And
so an ARM server, for example, which is booting UEFI, as long as I have TPM 2.0 chip.
So yes. So the two conditions are you need to boot EFI. We check that by mounting the EFI vars file system. And the second one, we only talk to the TPM through the command line suite that we imported in here, and that just talks to whatever it finds under /dev/tpm rm0 or tpm0 or something like that. So if you have the TPM compatible hardware that has the TPM API and appears under /dev using the correct driver, there's no reason it should not work.
Good.
It might be that TPM tools won't build for ARM. I didn't try that, but I wouldn't expect any like hard friction in there. I would be more suspicious about the ARM servers having something that looks like the TPM but does not have the correct API or something like that. That's where I would expect the friction. But if they can plug in TPM, yeah, I believe the interface is very similar to SPI, so it might be possible to just try that.
Sounds good.
Okay. I'll skip Flasher because that one's very long, and I'm getting a feeling that we need to get rid of the small ones first, and then start dealing with the longer ones. So let's see this one. So what does this do? Yes, here's the second time we meet the snippet for talking to the signing service to sign some bits. This time we GPG sign grab configuration, I believe. Yes. And we do one more thing, and that is that grub, by default, does not propagate secure boot configuration to the Linux kernel. So there's a small patch that grub knows this information and deliberately does not propagate it. So there's a small patch that actually propagates that into what was padding before. And we're planning to upstream this patch, so there's no reason it should not work. The only reason I can think of it's not like why it's not implemented is that the major Linux distributions use a different approach than we chose to like implement Secure Boot. And I can probably touch that after we're dealt with this PR. So for the sake of this PR, we need to propagate Secure Boot from grub to the kernel. Yes, so there's more things happening here. So we have another signing snippet. This is the one. So this one, the one on the top, signs grub configuration so that grub can authenticate it and load it correctly. So this means grub is already running. It's looking for a configuration file that it's gonna use for booting the OS, and this file would not load if it was not signed. So this adds the signature. While the one on the bottom, this one takes the grub binary as it is built and signs it for Secure Boot so that UEFI can verify the signature on the grub binary before grub is even executed. So in this patch, two different signing procedures are happening. And yes, if we're signing, we also embed the public key into grub so that it enters the secure mode and verifies the signatures. And this last snippet that is talking to the signing service is a bit different. It's a bit shorter. And that's because it's not signing, it's the one fetching the public keys. And in fact, it fetches the public keys that are later used here and embedded into grub. So this is the one we were speaking about before. Like we want to collect all these calls, fetching keys around all the recipes and package them separately and just have them available in the operating system so that we don't need to, have this call to the service in every recipe that randomly needs to access the public keys, which are public information. So we can as well ship them.
I have a question here to get like a little bit more context here. Do you think you can explain like the original pipeline of a Linux boot, and then how this if you want to do a secure boot, what you need to change, and then what you need to change for balenaOS maybe?
So I'll start with a regular Linux boot pipeline before secure boot, like I don't know, 10 years ago, let's say. It actually might be 15, but yeah, time flies. So you would have BIOS, which then looks for a bootloader, and which would be grub for most major Linux distributions. Grub would have a configuration file that would scan your drive or one of the partitions for a Linux kernel. And if it finds a Linux kernel, it would run it. Then the Linux kernel runs, mounts the root file system, and runs the user space. So that's a simple way of doing it. So with what changed with UEFI, this did not change that much actually. Instead of BIOS, you just used UEFI, and the grub has to be built in a different format. It has to be built as a UEFI application. So adding Secure Boot to it, the pipeline is still the same, but you need to have signatures in place. So Secure Boot, as I was mentioning, only verifies the first step. So it would verify grub, and without further security measures, grub can load anything. So that's where our current implementation in Balena OS starts drifting from the major Linux distributions. And again, I'm gonna come back to that. And yes, that's it as far as the original things go. We do the things a bit differently in Balena OS because our root file system is not a regular root file system with like etc def and all these directories. Our root file system is actually a Docker container. And after launching the kernel, instead of like a default init system that we would do, we have a custom thing called mobinit that is able to understand the Docker container and while mounting the raw partition, it is able to look for the root file systems within a root file system within a Docker container that is pre-populated somewhere in the partition, and bind mount everything so that it looks like we're running on an actual physical root file system on a partition. And only then we start the like regular user space thing. Sorry, I probably drifted way too far. I'm not sure how much informative that was, but
That was good.
Yeah, so this is a little difference between how we run user space in Balena OS and in regular Linux distributions. So let me elaborate on the how Linux distributions deal with Secure Boot and how we chose to deal with it and why. So I mentioned before that Secure Boot is a requirement for certification for like devices running Microsoft operating systems, and that is why most of the devices have like Microsoft keys pre-burned into them. So anything that Microsoft signs is bootable on the device. And Microsoft, through their developer portal, under certain conditions, will let you sign for a pretty low fee your operating system. Basically, the conditions are something like it's not malware, and we can verify it's not malware.
Okay.
So you can get your thing signed, and that's what most Linux distributions like Red Hat, Fedora, or Ubuntu probably as well. That's what they do. They have a very small bootloader. They injected a small tool called shim between grub and the firmware. They've had shim signed by Microsoft and just made sure that it is able to verify grub and everything else down the pipe. And so what's different with Balena OS is that they do not need reprogramming BIOS at all, because Microsoft keys are pre-flashed into it, and their small bootloader shim is signed by Microsoft keys, so they can boot whatever they want. And then the keys that they rotate are under their control, and they only need to like configure shim, not change the binary, but configure it to verify the new keys. This has some like benefits. This has some drawbacks. The main drawback that we saw is that you still have the Microsoft keys pre-burned, so you can boot anything on your device. And we were thinking about this for quite a while, and we don't think it matches our use case. Like our use cases are IoT devices and edge devices, which are most of the time single purpose, and there's no point like running anything else of them. It's not a desktop computer that you would have like multi-boot between, you know, Linux distribution or Windows or whatever you want. These are all single-purpose devices, and you usually only want to run one operating system with one application that you intend that you basically manufacture the hardware for. And so that's why we went with this explicit programming step, like nuking all the keys and keeping only the ones that you really need to boot Balena OS, and you need to run your application and nothing else. Oh my God, that was a lot of words.
No, it was good. I don't know if people have questions.
It's a good background.
I had some questions because, yeah, so just to explain to the audience who are not related with Balena, so we make, as we are a remote company, we meet up once a year. And this time we meet up, but yeah, distributed geographically. No, some people meet up in Seattle, some others in London, some others in Greece, and others in India. And you made a presentation of this, right? Explaining your work. And yeah, it was interesting, no, that some of the points that you were raising there, like, okay, so this is how Linux works, but on Balena OS, no, where should we keep our keys, no? How third-party kernel modules should authenticate with them, etc. So it's really interesting. We have questions from Julian. Can you elaborate on why did you choose group versus something else, like systemd boot?
Yes, that's a very good suggestion, and it touches what Alex was talking about before. So right now, what we need grub for is really the AB and automatic rollback mechanisms, because the logic that counts unsuccessful boots and unsuccessful boot attempts is in grub. If we were to re-implement this into our own bootloader that we are considering, and it's actually on our roadmap somewhere in the future, we would be able to ditch grub completely, and like any other bootloader except for the like Balena bootloader, we call it. So to answer the question, why did we choose grub? Historically, because it was already working with Balena OS. We're not 100% happy with it, and we have plans to ditch it. So it's likely to go away, but it just does the job for us at this moment.
Very good question. More things. So actually, one thing that I completely forgot is that once per hour, we do like a progress status. And we completely forgot checking Jenkins tasks and so on.
Status is going to be easy. It's always going to be waiting on Jenkins.
Exactly. But yeah, in 10 minutes we should do kind of a share progress with the audience at some point, and then maybe we can chat about something else if we have to.
Let's check on Leviathan. Okay, let's check from the PRs actually. That's gonna be aggregated, and we're gonna go back to grub. It failed. Come on.
No.
I think Brian was telling me that there were some troubles with some jobs. Maybe it was powered off by mistake.
By mistake. I see.
So now we can show that you can go to the PR and you can just retry it if it hasn't been done already.
Oh yes. I can do the job, right? I need to make sure I'm not in the set metabalena status. I'm here.
Make sure it hasn't been relaunched already.
So this is the peak driver still. This is Ryan. So I assume this is my. No, I should have go to the PR. So again, this one. So it's Leviathan 650 failed.
Yeah. So
output broken it. Test unfinished. Okay. Fail. Oh, okay. There's some 500. That's probably the cost.
I think it was powered off. I think. Yeah.
Okay, so I can just retry, and it's gonna get back into the queue.
Check that it hasn't been retried already. Just make sure that the pending jobs are not.
They're not. There's one running. That's Ryan's with QEMU, and this is the one for the peak driver. The first one reviewed, basically.
Okay.
Okay. So we can go back to this PR. And yeah, I described what's happening. So I'm waiting for comments from Alex.
This is the PR we just discussed, yeah?
Yes.
Yeah, I don't think I had any comments on this one. Apart, I mean, we've already spoken about separating stuff in a class, and we had the last lines.
We have been speaking about we are not sure why Yocto makes us split into like native and target builds for grub, but yeah, that's something we need to figure out.
Yeah. Do you want to leave? Do you want to leave this PR without? I mean, we have a queue of PRs, so what we can do is we can work on finding out why we need that empty native class there, which we shouldn't do. We shouldn't need really. At least I would like to have reason to add that. So we will build this locally, see what happens when we remove that. You said it failed, which means that something is introducing a dependency on a native build of grub, which is weird. So we'll pull that dependency, see what that is, and see if we understand what's going on.
So do we leave it unapproved for now?
Yes, for the time being.
Okay.
Yeah. I mean, we'll have to do some actual work at some point. So.
So this one is based on it, I think, but we can touch it. At least discuss it. So yes, I'll only filter for the one commit in question. Okay, so this touches the second stage bootloader that we were mentioning multiple times right now. And as a part of this project, we have implemented poor man's version of this, where our Balena bootloader is not a dedicated small kernel that would only be a bootloader, but we actually use the same kernel that the OS then later uses because it has all the functionality we need and much more that we don't need. So we want to minimize it in the future, but it does the job for us now. And so why did we need to pull this into this project? So originally, different. So unlike other Linux distributions, we don't keep our kernel in the boot partition, unlike what you may get from this path. It's not in the boot partition. It's kept as a part of the Docker image that contains our rootfs. And all our tooling is counting on that, and we are able to mount a rootfs and look into a particular place to find a kernel. So the problem is with full disk encryption, the root partition is encrypted. So grub cannot just look into it, and it has either to unlock it, like use the TPM to actually decrypt the partition, and after that it could look into the root file system, find the kernel, and everything works. Or we need to do something else. So initially, we thought we can do this with grub, because grub has modules for talking to the TPM. Grub has modules for talking to like looks, encrypted file systems. But it turns out they do not play very well together. Like the TPM module in grub is only used for measurements, for verified boot, basically checksumming the boot chain. It's not able to use the cryptographic API. We've tried to hack it into grub and add support, but it turns out that's a lot more work than we anticipated. So that's why we decided to do this as a first step toward the Balena bootloader. And how it works now is that we only have a very dummy configuration file for grub that does the counting. It's this one up here. And sorry. So this is only true when full disk encryption feature is enabled. If this is not enabled, then it behaves as before, like it's the current generic x86 device type. So if full disk encryption is enabled, we, instead of the main balenaOS config, we pull in this one, which is much simpler. It only does the boot counting and switching between root A and root B. But other than that, it always appends Balena stage 2 kernel argument, and that's it. So after this loads the kernel, our chain of RAM disk script are executed, and at some point, the RAM disk is able to decrypt the drive using the TPM. So at some point, it succeeds mounting the rootfs, and the next script, which is a part of this PR, can look at the decrypted partition and look for the actual kernel. So if it finds that it's in the stage 2 phase, as we call it, and if it can find a kernel, then what it would do, it would find the root partition UID, because it knows it now, it's decrypted, we know the file system. It ditches the Balena stage 2 parameter from the kernel command line. It replaces the root parameter with the actual root that we want to mount, and executes the newly found kernel. This looks like a very fast reboot, basically, on the device. And it helps us work around the issue where grub does not need to unlock the partition, and we can still update the device, because this kernel, the kernel that basically this one that gets filled during build, is a single-purpose kernel that is only used to find the real kernel, and that one is then booted. So again, a lot of words. To summarize it somehow, we run grep. Grep is not able to decrypt the partitions, so the only thing that grep does is it counts boots. It is able to swap between root A, root B. It runs a single-purpose kernel whose only job is decrypt the partition and find the real kernel, and then execute it. That's the short story. And I'm open to comment if something was not clear, because I feel like it wasn't.
I think it was well explained, Michal.
Yeah, it was probably boring for people without OS knowledge, but yeah, that's how OS work goes usually.
It's the same concept we are planning to use for the Balena bootloader we were speaking before.
It's a very same concept. It's just
we want a kernel that launches another Linux kernel, basically. The first kernel, we can make it very small and very specific. So the only part that's missing from here is that we to remove the bootloader, the grep or gboot from the question is we need to move the logic that deals with the AB partition to this extra new kernel bootloader. And that's a work in progress. We just need to retake it at some point.
Exactly.
So this will stop to be something that we just have to do for encrypted boots, for secure boots, and we will do that in general for everybody always.
Basically, the script is likely to stay the same or very similar. What's going to change is how the default Linux that grep loads would be built.
Because the result of the Balena OS, the output of these, it will be like a special operating system version tagged like for security, or anyone will be able to use it if they have a generic x86.
So the idea is all the features will be in the generic x86 64 device type. If prior to flashing, you enable Secure Boot and configure it with the proper keys, then it would also enable full disk encryption and enter the secure mode. And if you have Secure Boot disabled, it would behave as it behaves now, because we suggest disable Secure Boot and there's no encryption in place.
So we should say that you cannot do a host OS update to a Secure Boot system. You need to flash. So you need to
reprovision the device.
Okay, that's interesting.
It's the flasher image that will detect that you are booting in Secure Boot, and it will do the partitioning and the encryption of the partitions.
Yeah. Because we already mentioned we need to repartition, and it's very difficult to do on running systems. So to enable the feature, you would need to reprovision the system.
And and this can be automated. So I mean, if I start from scratch a project, that's not a problem to provision n devices. No, every device will have its own key, and it will be provisioned during.
Yes. So as far as Secure Boot keys are concerned, they're the same for all the devices.
Okay.
When they register to Balena Cloud, they would all get their own.
So it's us that keep the private key secret.
Yes.
It's a Balena.
That's why we have the signing service. Basically.
Yeah, the Balena sign.
The private keys never leave the service, and the device that is physically at Balena controlled premises. And it is only able to perform the cryptographic operations, but it will never give you the key so that you can do the signing yourself.
Okay, that's interesting. So if I steal one of these devices, I don't have the private key, right?
No.
I need to ask to Balena.
No, that makes sense. There's no API. Even the signing service had no API for exposing the private keys.
Okay. So we are on the top of the hour, right? It's 1 p.m., at least here in Barcelona. I'm not sure what time is it on your site, Michal.
It's also 1 p.m.
Okay.
Yes.
So
And very
it's
surprising in La Rioja is the same time as Barcelona.
yeah. So I don't know if Michal had another time zone or not, but yeah, it's 12 p.m. UTC. Maybe it's time to explain progress. If you are here, welcome to the 7th release party. We have been doing previous release parties to deploy Balena Hub, the menus on Balena Cloud, documentation, and so on. So this is the number 7, and if you are here, you're watching how to we are deploying balenaOS, Secure Boot, and full disk encryption. And at this moment, we are trying to update MetaBalena, and I'm not sure if you can give more technical details, Michal, Alex, here.
I think I can wrap it up. So at this point, we have the feature mostly ready, split into multiple PRs over 2 repositories in general. So the first one is MetaBalena, which we are working on right now. This is a common base for all our operating systems for each device, not necessarily for the generic x86 we're targeting. So we want the feature to have, we want the feature eventually available for everybody. So we're putting it into the common base. And over the last 2 hours, besides chatting about the feature, we were just going through the PRs, giving some of them act, giving some of them, or getting some of them tested, and basically just discussing and brainstorming live on the stream. The goal is to have everything emerged into MetaBalena, prepare a release of the generic x86 64 device type, deploy to staging, and see whether it works, and eventually release to production later. So we'll see how it goes.
And how is Jenkins right now?
So
can we check that everything it's performing properly, or?
no, we're still waiting
Okay.
for Ryan's QEMU job to finish.
29 minutes. Okay.
So I'm starting to feel we'll eventually need to batch some of the PRs that we act quickly together so that we reduce the number of Jenkins rounds we need. But let's discuss that in a while.
We could force merge some of them. I mean, if we think coldly about it, the only test that Jenkins is doing is running on a Raspberry Pi, which is not exercising the PRs themselves.
Yes.
Yeah.
So we are not missing much. So we'll give it a bit of time, but if we have to, we can just force merge some of them. Should we continue with our PR revisions? I feel that we have quite a while, quite a lot of them to go.
I think so.
I mean, if we finish doing the review of the PRs, then we'll start to force merge, so that we can move forward.
Mm-hmm.
So let's move forward. Yeah. How many PRs did you make?
Let's see. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay, and we cover 4?
We've covered 4.
Okay. Let's move forward. If that makes sense to you.
Second?
If that makes sense to you, let's
let's
check
get
all
them
the PRs
out of the way. So, did we go through this one? Yeah, I was talking about the second stage bootloader. So
this is completely fine, I think.
Okay, this fails to build because on one of the device types, util-linux timeout is not available, and I'm not sure why.
Which device type is that?
TS4900. Let me check. So,
Can you scroll up? What version of Yocto is this device type on? At the beginning, there is like a dump of SHA-1s, and I think we should be able to tell. Or even there's a list of the layers. Scroll down a bit.
You need to guide me.
So here, when we yes,
here,
when we do the layers.
Now I just clone them from Git.
Yeah. Okay. That's not what I was looking for. And a bit more down. Just before it builds, there's like a summary.
Oh, here.
252. Yes, that's what I thought. That's sold. So we would need to append that recipe for this device type.
Okay.
Can
you do that live?
Can you do that live? Yeah, let me check first what version that is. We said 2.5 Sumo. Yeah, I need some time to set up. So I'll need to clone the project locally. I'll need to build it first, and then I can. So I'll tell you guys when I'm ready, okay? I don't know, what do we want to do then? Because are you going to, who's going to review the PRs? We need to call somebody else in.
Exactly. Let's call someone else who can help here. Or on the other hand, I have a bunch of topics that are off topic from this release party that we can cover. I got prepared.
Let's ping the team.
Okay.
I mean, you can give a background on why we do release parties. I would, although 5-minute break, and then we can catch up in a bit.
Sure, yeah. I can introduce why we do release parties, actually.
So yeah, I'll be back in a few minutes.
Sure. Yeah, feel free to turn off your camera if you want to stop. Yeah. So why do we do release parties? That's a very good question. So actually, as a remote company, so what we do, it's kind of celebrate like a new how. So we meet up all together to share how we release features all together here live, to work in the open and to show to the people, like the Balena culture and how we do things, or how we do like to do things. And and this is how we started a year ago. Actually, we will cover as well how we decide to implement features like the one that we are doing. It's really interesting as well to learn the framework that internally we run at Balena to decide what to implement or what not to implement. But it all started a year ago, probably, with a customer complaining that they didn't get metrics from their devices. So the hard disk from their devices were completely full, and they didn't know. Just checking on Balena Cloud, the devices themselves, they need to get into the SSH and check for the memory available. And so, I didn't mention that, but Balena, we are a support-driven company. Everyone at Balena is on support. And so we catch that pattern on support, and we decided to implement that and to implement it in the open. So as I said before, we like to work in the open. So we decided to do it live on YouTube stream, like today. And that was the release party one. So we implemented the metrics that now most of the Balena OS probably devices have already implemented, right, Alex? If I'm not wrong.
Yeah, live.
Yeah, and from that, I think second release party was about Balena Hub. If you don't know about Balena Hub, it's an IoT edge application marketplace. We will cover that in some moments. We will explain in more detail what's Balena Hub, what type of projects you can find there. Of course, that there is a challenge, or you can get like some thousands of pounds if you submit your application or project on Balena Hub. We are going to cover that on some moments. So we have been using during the last year these release parties actually to meet up here. I'm not usually meet up Alex or Michal or Ayan and we celebrate how we release features usually. So this is like a way to do it all together as we were in an office, right? Maybe as well, Alex, it's interesting to cover how we decide to implement a feature. Would you like to cover that?
How we decide to implement a feature? Okay.
Exactly.
So as you mentioned, we are support driven. So we have a lot of contact with customers, continuous contact with the product. And we have a system where we identify patterns on support. So every time that we hit a problem with a customer, we look for a pattern. If there is not one, we create one. And these patterns, each time that they are being found, they keep a list of the support tickets that have raised it. So one of the things we do is we identify those patterns that are causing the most friction, and we prioritize the work to fix those. The second way we work is to look in the long term for the strategy of the product. So we also have a lot of brainstormings where we decide how the features are going to be implemented and how that fits with the roadmap and the vision for the product. So as part of that long-term vision, we all participate on a project. So we're all assigned of a project of something that is important for the future of the product. So things like Secure Boot, for example, that's been a long-running project, and a lot of other things. So that's the second way that features are introduced. The way that these projects are chosen is both things that we identify in our brainstormings that are important or strategic or part of the architecture of the product, but also things that come through customers, also via support or via customer success team. So I think that a mixture of the input we get from support and the vision that the company has for the product, that's how we decide what to work on.
Exactly. That's very interesting. This is something new that I never had before, like this support-driven experience. This is really interesting, at least from my point of view. And now that I have you here, Alex, so what's next on balenaOS? Can you explain a bit the roadmap of balenaOS?
Yes, things that we're working on currently on balenaOS. So we are working on the AUFS to overlay migration. So as some of our listeners might know, Docker in their most recent versions have job support for AUFS. And for a long time, that was the default storage engine for balenaOS. So we have some legacy device types that were introduced years ago that are still on AUFS. So we've been trying to work on this for some time. The way that the upstream Docker is approaching this is like, okay, Docker will just re-download apps with the overlay engine, and that's it. Now for our customers, we have a lot of customers which are very cost sensitive. So they are, for example, on cellular networks, and the idea of paying a huge bill just because we are deprecating AUFS and they have to re-download applications, which in some cases they are gigabytes of data per device on a big fleet. That's something we wanted to avoid. So we've implemented a mechanism in the engine that when the engine starts, it will migrate AUFS applications to overlay, hopefully without any problems. And that's about it. And we are currently at the point where we are starting to deploy these. We didn't want to do a while deployed to all fleets. So the way we currently work with balenaOS is when we introduce a feature to MetaBalena, it takes some time until that feature, that MetaBalena version is updated into all device repositories. As part of this release party, we spoke about how we are moving to have a better automated testing, and we are hoping to get to a point where we can automatically merge APR and deploy without having to wait, but that's not the case. So there's a delay right now between a feature appearing in MetaBalena until it actually gets to a device type. So we are taking advantage of that delay, and we have just released the AUFS migration to overlay for the bigger bone fleets. We're going to give it some time. So we have some stats on that. We're going to see how the uptake is. We're going to be very to have an eye on our support channels, see whether that's causing any problems for customers or not. We want to make sure that the feature works flawlessly before it reaches our bigger fleets. But hopefully in a couple of weeks' time, we'll be in a position to update all of the device types that are currently on AUFS to overlay too. So that's one thing we are working on. Another important thing we are working on, we've been working on for a long time, is the concept of extensions to the OS. So the problem here comes with the fixed size of our partition tables. So we have fixed size for root partition tables, and the idea of modifying that on the fly on a device which is on the field is not very appealing. It's a very complicated process. So we came up with this idea that actually is opening a whole set of other possibilities of building a container extension that can then be plugged into the OS and will overlay the root file system, and we can use that to extend the root file system with new functionality without actually having to increase the partition sizes. They can be optional. They are going to be managed by the supervisor, and they are going to include things like kernel modules. So the idea we are playing with is that we could actually have a bunch of kernel modules, as many as we can, pre-compiled as extensions, and then it would be as simple as a customer, when they are designing the Docker file for an application, to reference that they need a kernel module, and the supervisor will then download a pre-built kernel module and install it. Because the story with kernel modules has been a friction for customers for a long time. So this feature opens the possibility to simplify the way that we handle kernel modules. And this feature has been on the work for a long time now. So the main problem we have found has actually been on the cloud side and the API. So the work for the OS to mount these extensions is done. It has been done for a while, but how the supervisor is going to manage the extensions and how the cloud API is going to identify and manage the extensions, that's work that is currently in progress. So that's the second important thing that we are working on. We are also working on a bunch of other things, like some people might know that we have a migration, what we call a takeover application, so that we can migrate a device which is running a different operating system like Raspbian into balenaOS. We are working on improving that, extending the support for different operating systems. We are also working on the Balena bootloader, which we have touched in here. We've been
Alex, the previous one, sorry, the previous one, this is the brownfield migration?
The brownfield migration, yeah.
That's super interesting how
Yeah. So it's becoming very important, especially now with the chips shortages. We have customers that approach us and they have existing fleets that run on a different OS, and because of the impossibility of finding new hardware, they want to reuse the fleets that they already have. So this is a product that is becoming increasingly important for us. So we are dedicating resources to it.
That's really cool.
So yeah, I think that gives an overview of features. And of course, we have the day-to-day things. We are also in the middle of an update to Honister release. So we found out that for some of our device families, the Jetson family, for example, if we wanted to take advantage of some of the new features that has been released with the new BSPs, we needed to update the Yocto release to Honister. And even though it's not a long stable support release, which we usually prefer, it introduces a change in syntax. So we thought it was worth doing that change as quick as possible, see what kind of problems we find, and in that way helping the Jetson device family also update. So we are also working on updating the Yocto release, and with that updating all of the packages that we control from Balena, things like Network Manager, Modem Manager, all the different applications that we use in the host OS. I think that's a summary. I'm probably missing things, but that's what I can remember from the top of my head.
Wow, that's awesome. That's a really interesting roadmap with super useful things, right?
Yeah. I think I've been very excited with extensions for quite a while. It's a pity. I mean, it was a more complex feature than we anticipated, and as you know, we don't like to rush. We like to put the time it takes to do things properly. But once it's out, it's going to open a new set of possibilities. We are working towards a more modular OS. So right now, as it's known, we update the host OS as a container, but it's a single container. We are moving towards being able to separate the OS on different container blocks.
Oh, wow.
So that, for example, we would have a container block for the user space, which is it only depends on the architecture. So we can have, for example, a container which is built for AMV7, and that's going to be a common container that's used for all the AMV7 device types we have. And we can separate things that are device specific, like kernel or device trees, to a different container. The idea there is that we make it easier. We reduce the friction for people that have some type of custom hardware, things that happen, for example, when you're using a module like a CM3 or a CM4, or you're using a Jetson. So you have a module, and then you just design a board, and all you need really is to customize a device tree for your board. Right now, that means that we have to add a new device tree to the host OS. If we would split that into its own container, all that you would need would be to build a container with that change, and then our build system would just pick the different container blocks and put them all together to build the host OS. So we are moving towards an architecture where everything is going to be modular. We are also planning on splitting things like networking into a different host OS block, so that people can choose what type of packages they want to use for networking. So we would have to define an API of what the blocks has to offer for it to work with the rest of the OS. But if that API is met, how it's implemented, it would be not a concern of the OS really. So yeah, that's opening a lot of possibilities in the future.
That's super interesting. There is a expected time of arrival of these, or this is?
Well, I'm a bit. I don't want to give any expectation because we, as I said before, we thought the work with extensions would move much quicker than it did. We found some unexpected things that need to be sorted in the architecture of our backend, and these things are never easy, especially because you have to make these changes while supporting a working product. So I don't know. We are actively working on it, but I cannot provide any timeline for it.
Yeah, that would be a big change, right, for some projects as well.
Yes. The main motivation we have is we want to reduce friction for introducing new device types. We want to support all of them really, and we've known for a long time that it's not sustainable a model where Balena has to take the work of introducing new hardware because the friction is too high. So we know what we need to do to reduce that friction. We have a plan for it. We just have to massage the architecture until we get there. But I would expect that any of our customers should be able to introduce a custom hardware and build an OS for it in less than a week.
Oh wow, that's super interesting. Because that was one of the questions as well that I had on the time out that we have. I don't know, Mihaly, if we should come back to the peer review or can I continue asking questions to Alex?
Sorry. When I was leaving, Alex was working on the TS4900 thing. So how's that going? You just interrupted him with your questions, right?
Okay. So yeah, some of the other questions I had on my script is, so if I'm a hardware manufacturer or I want to release a product with a hardware that it's not compatible. Well, it's a single board computer, of course. It's ARM or Intel, but if it's Intel, it will be easier, right, with an x86. But if it's, for example, ARM, what's the process to create or to make like a Balena OS compatible with my hardware right now?
So I can try to answer that. I think Alex has a better answer.
Sorry, I was checking on the team whether we had the volunteer to join or not. Could you repeat that? I wasn't paying enough attention.
So if I'm a product manufacturer, a hardware manufacturer with and I release a product that it's not compatible with Balena OS, so what are the steps that I need to do to make my product compatible with Balena OS?
Okay, so the first thing to check is whether we already support any device type on the same family. Okay, so if we do, we probably already have a repository in GitHub, and it's a matter of doing the changes and issuing a PR to that repository to add the new device type. Usually, it's as simple as it needs a new device tree, something like that. If not, so if it's completely unsupported, you would actually need to create a new repository. We have instructions for it in the documentation, but you need this new repository, you need all the Yocto layers, and you need to add the support yourself. Now, the main things when adding a new device type is the bootloader and the kernel. So as I said before, the kernel is pretty straightforward. So we typically, the BSP that the vendor is providing for device type already builds a kernel. We have a class in Balena, so it's basically just a matter of modifying the Yocto class to inherit the Balena class, and that's about it.
Okay.
The bootloader is where most of the friction lies. So right now, when you introduce a new device type, you have to modify the bootloader in order to work with Balena. So we have the AB implementation. We need specific variables in the environment. So you would have to go and see how it's being done and do the change yourself. And that's usually got quite a lot of friction, because not only you have to understand very well the hardware and how that specific hardware is booting, but you also need to understand what changes Balena is introducing and make those work. We have a plan there, as I mentioned before. We want to introduce this Balena bootloader. That would mean that no changes are required. So as long as the vendor bootloader is told to boot the Balena bootloader, we would just have this piece of this kernel that deals with all the complexity without having to modify it or patch it. So that's the shortcut. It doesn't sound too complicated when you speak about it. Now, the theory and the practice are a bit different. So there is the unexpected, there is the I think most of the challenge is understanding how Balena is booting, understanding the way that the bootloader is identifying the root partition and passing a UUID of the file system, which is going to act as a boot partition. Some device types are a bit more complicated than others. Theoretically, as long as that device type has a Yocto BSP and uses either uboot or grab, it's something that we can support.
All right, so everyone knows now how to make their product compatible with Balena.
Yeah.
I wanted to show to the audience that we want to hire people. So I wanted to get into the hiring page. Is that okay for you? So you can work behind the things? Yeah. Makes
you
sense.
Said you would let me work a bit, so.
Exactly. I think you need to work a bit, and maybe I can. Let me share my screen. So if I share my screen, do you see my screen? Do you see the careers at Balena? Or you don't?
I don't.
Can you check that on the stream yet? Yes, no?
I do, but I don't know if it counts.
Yeah, it
yes.
is.
Okay. It's a yes for me.
So we have some jobs opening. We used to do this at IoT Happy Hour, and I hope that it's being done at IoT Clinic every Friday at 4 p.m. UTC. But yeah, we are searching people to work at Balena. So if you are interested in what we are doing here, you would like to work in the open, you would like to, enjoy our culture and what we do, and you think you can help, we have some positions open. And of course, we have our design your own role. Maybe this is a good question for you, Alex and Michal. I will not let you work, actually. So how did you apply at Balena?
How did we apply?
Exactly. There was like an opening position for you, or did you apply as design your own role?
There was an open position in my case.
Okay.
So I just saw a good match and I applied.
Okay.
So in my case, I was already in a notice period with my previous company. I had no idea what I'm going to do.
Okay.
And a former colleague of mine who was working at Balena at the time shared how wonderful Balena is and how everybody should work for such a company. So I've tried applying and it worked. That's my story.
Oh, nice. But did you apply as design your own role, or how did you apply?
No, I believe I was referred internally somehow, and
okay.
I was contacted by Balena.
So that works as well. Wow. Okay, that's cool. So these are the positions that we have open. But as said, if you think that you can do something else that it's not here, feel free to apply as design your own role or to ask for referrals for people who is working at Balena. So we are searching a hardware engineer. I'm not sure about this position because it's new. But the idea probably is to help the Balena Fin team, probably. Yeah, so if you want the Balena Fin team, it's super cool. So if you want to help to design the new Fin 2.0, Anush was mentioning that before, no? Arijit was asking about the Balena Fin 2. So if you want to help on the designing or defining the requirements of the new Fin, we do something that it's very cool, that it's Alex was mentioning before as well. So we want to do everything very modular, and even hardware is very modular here. So we like to do like this depopulation as well, and so on. So if you think you can help on hardware and on a schematics PCB and so on. So yeah, this is probably a good position to apply. We are searching a software engineer for product development platform. So this is a position for product OS. Actually, yeah, maybe we can mention this in some hours or some minutes. How are we structured at Balena? We are structured on different teams or loops, and one of these is the product OS team, who actually it's helping, it's enabling, as it says here, it enables the Balena team, the developers like Alex or Michal or other developers to, build products. And so if I'm not wrong, this is probably going to the Jellyfish team. And to help the team to work better and to define patterns and so on. What else we have open? Data lead. We are a support-driven company, but as well, it's really interesting how we take care of all the data of what's happening at Balena. So if you are a data scientist, probably this is an interesting position for you. And we are searching SREs, or site reliability engineers, in Europe time zone and in America's time zone. So if you are a site reliability engineer, I think this is a great opportunity for you to apply here. And finally, if any of these actually matches of what you do or what you would like to do, feel free to design your own role and explain what you can do for Balena and what Balena can do for you. And this is like, I have been speaking, like, as I asked to Alex and Michal, to a lot of Balenistas live, how they applied at Balena. And a lot of people sometimes try to apply as a hardware engineer, but that didn't work, and then applied as design your own role, and that worked better. So I invite anyone who wants to join Balena to do it with design your own role. And that was about the jobs opening. Okay, so let's see if Anush wants to join us. Give me a sec. We have Salmon saying hello from Tenerife, Alex. Okay. Let me explain. Let me explain the Balena Hub challenge because this is something interesting if you're a developer of IoT or edge applications, what it's happening on Balena Hub. Let me share my screen again. Right. So this is Balena Hub. If you don't know what is Balena Hub, this is actually an IoT edge application kind of marketplace where it has been developed on release parties, on different release parties. I think the release party number 2 and 5 or 6 has been devoted to Balena Hub. And you can find here a lot of different fleets, projects, and blogs that you can take the benefit of these to distribute your software for IoT and edge applications running on Balena. We do have the fleets and projects. Actually, fleets are open fleets. That means that if I want to get Balena Sound at home, I only need to get started. And I will download a balenaOS with I'm not sure if this is already preloaded or not, all the containers, but I will introduce my Wi-Fi credentials here, and I will get a balenaOS that will belong to the fleet of this user. In this case, this is Balena Labs. But you can actually submit your fleet here and enable anyone to take part of your fleet. So we have different, actually, this is not order, but we have this Balena Raspberry Pi Play with more than 1,000 active devices during the last month. We have the Rosetta at home. We have other applications that are not from Balena people, like Ribbit Network, which is a citizen science project where people from all around the world are installing CO2 sensors just to be part of this citizen science network to understand in a crowdsourcing way how CO2 is behaving in worldwide. We have other applications that I am very proud of. For example, Birdwatcher. It's an application. It's a fleet actually that you can join, where you can have a bird feeder and with a camera and a Raspberry Pi or a Balena Fin or similar, and take pictures of the birds coming to your bird feeder, and with a machine learning system with edge impulse, detect the birds coming to your bird feeder and sending the images and the name of the type of bird, etc., through Telegram, for example. So that's really interesting. We have the projects that are actually Balena fleets as well, but so not all the people just belong to that fleet. So for example, I did this Helium data hotspot, where you can come here and just fork this fleet or go to the source code, and you deploy it on your Balena Cloud. On open fleets, on Balena Cloud, you didn't need a Balena Cloud account. For projects, you need a Balena Cloud account. And finally, we have blogs. That this is surprisingly growing a lot as people find this super interesting. And we have plenty of blogs. And are actually, sorry, the blogs are like pieces of or modules that makes a feature or something, but themselves alone don't do anything special on the device, but help you as a developer to accelerate the development of your fleet or your project on Balena. So actually, if you are developing something on Balena, just feel free to come to the blogs and see that if you are developing right now, it's already done here or not yet. I hope that at some moment we will have other people from Balena Labs, etc., that can get deeper into Balena Hub. But I wanted to come here just to talk about the challenge. Okay, it's because we have an open challenge. The deadline is at the end of the month, so you still have 3 weeks to apply or to submit your project at Balena Hub. But the idea is that if you have an IoT or Edge project running on Balena, you can apply. So you can submit it into Balena Hub and apply for the challenge, and you can get prizes of £2,500 in cash in case that you win the challenge. But I think that it's as well really interesting to mention that some of the prizes as well are being featured on Balena Etcher. So if you never use Balena Etcher, maybe you have seen that we feature some projects. Meanwhile, the SD card or the USB is being flashed. So yeah, being featured there means that there are millions of people are watching about your project per month. So it's a great way to get exposure and then allow people to use your project and be part of your fleet in case it's an open fleet or not. So submit your project here and create a great open source project and submit it here on Balena Hub and on the challenge to try to be part of this great challenge. We are looking forward to have more and more applications and projects here and blogs. What else?
Yeah, I was saying hello to the person from Tenerife before, but I was muted and I didn't realize. So hello again.
Hola, hola.
Hola, hola.
So how's it going? And I let you work for some minutes.
Okay, I mean, I can share my screen. I'm not done yet, but I guess if there's not much else.
Okay.
You guys seeing my screen?
Sure.
Okay, so the background is we were reviewing Apia with Michal, and we realized that it failed when building for one of our device types, the TS4900. Now, this device type is based on an old Yocto version. It's based on Sumo. And the reason why it was failing is when we build, we are specifying a dependency on the recipe on util Linux find mount, and it's not finding that package on the build. So my suspicion is that in Pokey, which is the Yocto layer that contains a recipe for util Linux, they have split the find mount utility to a different package. So Yocto has these concepts of recipes and packages, and they're not the same thing. A recipe is a set of instructions that you place into a .bb file that explains the system, how to build some source code. And that recipe can then create one or more packages. So of course, you could just build your source code and place it all on the same package. The word package here comes from the distro package. So this is like a dev package or an RPM package. You can use what package format, but Yocto in the end is compiling your source code into a package format. In our case, it's OPK, but it can create from the same source code one or more packages. So in this case, what they've done probably is they've split find mount into its own package so that if you only need the find mount utility, instead of having to include all the applications that are built from util Linux, you can just specify the util Linux find mount package and you only get the find mount utility. This is something that Yocto does because it wants to optimize in size. So Yocto is a build system to build a distribution for embedded systems, which typically are constrained in resources. So this is one of the things they do, while on an upstream distro like Debian, you would have no problem installing a package called util Linux, and it comes with 20 or 30 different applications, different binaries. With an embedded system, you want to be a bit more specific. So if you only need a utility like find mount, you don't want the rest, you should be offered the possibility of installing only that utility. And what probably happened is that that split happened on a Yocto version above Sumo. So sorry, let me cancel that. So an easy fix is, instead of having to depend on util Linux find mount, is just to change that to util Linux. But I wanted to verify that. So what I'm doing now is I did a local clone of the TS 4900 repository. I want to build the util Linux package locally. I want to look at the contents, and I want to verify that when I build the util Linux, I have a find mount utility. And then what I'll do is I will include a bb append file. So Yocto also has this concept of appends. You have the main recipe, which is a bb file on the Pokey layer, but then you can append that recipe on any of the other layers, and that's called a bb append. So I will append the recipe just for Sumo, so that we change this dependency and we add the correct dependency. So that's what I'm working on. So what you're seeing in my screen, if you are seeing my screen, yeah, can you confirm you're seeing my screen, guys?
Yeah, sorry, I was mute.
Yes.
Yeah, we could see your screen.
You can see the terminal, yeah. Okay, so
yeah,
I have
exactly. I could
three
see
boxes.
exactly.
Yeah,
Three
so
terminals.
the one on top, it's actually building. So I just run a bit-bake build for util Linux, and that is progressing. What I have at the bottom is I'm going to browse to the folder where the Linux is built. So hopefully I will be able to explore the packages content, and I want to find that find mount. And on the right side, I was looking at the util Linux recipe in Pokey, just to make sure that I wasn't missing anything. So I'm just in the process of building and checking that find mount is there, and I'm going to prepare my bb append to the recipe. So that's what I'm doing. It's a bit slow because you have to wait for things to build locally, but I can actually start by working on MetaBalena. So I'm already I've done a checkout of the branch that Michal has pushed to upstream, and so this is a change. Okay, so if we see down here, we have these R depends, and it's depending on util Linux find mount. So what I want to do is I want to add another bb append, but this time to the meta Balena Sumo folder that will override this variable and change, instead of util Linux find mount, we will just do util Linux and see if that fixes it. So I can probably go ahead and do that. So we have a meta Balena Sumo. What happened with meta Balena Sumo? Maybe it's not Sumo. I'm confused. Let me just quickly find out what we are building. So there is a bblayers.conf configuration file that will tell us meta resin Sumo. Okay, that was okay. Yes. So what's happening is that if I go into the layers, okay, so this is, let's see the original, how this looks originally. So let's do a git submodule update. So there's an extra complication here that I should mention. I've said before that we are in the process of updating to a Honister release. And Honister is bringing a new syntax to Yocto. And the way we are planning to deal with that is we thought of updating the syntax in MetaBalena to the new syntax. But then if we have to build a device type that is not on Honister, so it's not using the new syntax, we would have a script that converts the syntax from new to old at build time. So that's a bit of a problem here when you are developing, because that's only temporal until we actually update the rest of the device types to Honister. But right now, as you see, we have a lot of changes because the script has actually, so if I show the changes, so the script has actually replaced the syntax. So it's changed the underscores that were used in the Yocto versions before to a colon that is used in the new ones. So when developing, it's just a bit more complicated because you have all those changes. So I just get rid of them with a git stash save, then I should be able to update. Now it's a clean. So now it's updated. Just wanted to see how it looks like before I went to. Okay, yeah, so here we have a meta-resin sumo. Okay. It's really sure what happened with the meta-resin folder. So let's go back. Oops, missed the graph, did I? Okay, so I wanted to check out this branch. Okay, yes, meta-resin sumo. That's what I was looking for. I just got a bit confused with all the changes. Okay, so let me open a new window. And we were saying we have Pokey. Pokey has a util Linux recipe. Let's find that. Okay. It lives in recipes core util Linux. So in meta-resin sumo, we want recipes core, and there is a util Linux here. Okay, let's have a look at that. Okay, so we have to complement that to override the change that Michal has made. So this is where I find my laptop screen a bit small, because I actually I can reduce this one. So I want to use I want to go back to MetaBalena to actually see the change. Okay, so once I have the change down there, we can probably. So I have to remember that's using old syntax. So we want to go back to underscores. Okay. And we want KSX tools, and we want util Linux. Hopefully, let's see what happens here. So what I need now is to run the conversion. So just for the sake of my own well-being, I'm going to add that change. I will modify the commit message later on. I just don't want to lose it, because once Varis does its job and modifies all the recipe, I will have to find out what I changed again. So in this way, I just commit it first so that I don't lose it. And then I go back to my build. Actually, maybe I can do it up here. I think I have, yes, I run Varis. So just to give a bit of background on Varis, this is a script that we run basically to prepare the project in order to build. So for our cloud, we use some metadata that we keep on coffee files. So one of the things that Varis does is it converts these coffee files into JSON, and these coffee files and JSON files are then going to be deployed to the cloud, and it contains some metadata that the cloud application is using. So the very first thing, if you go into the device repository and you check the instructions to build, the very first thing it says is use Varis to build. So this is a bit, it's not standard Yocto. In Yocto, you would just do a bit bake. You would first prepare the environment. You would source the open embedded script that sets up the environment, and then you would call bitbake and build. With Balena, we have Varis, which is doing all of that. So it does the pre-processing of it, also source the open embedded to prepare the environment, and then it runs bitbake to build. But here, I'm going to run it with a -n, which means it's a dry run. I don't want it to start building. I just want it to run because I want to do the conversion from the new syntax to the old syntax. Some of the things I'm telling it, I'm specifying the machine type. So it's a TS4900. I'm saying it that I wanted to remove the objects from the working directory after it builds because I don't use them. I'm specifying a folder to download the shared downloads, and also a shared state folder. So when I do this from the correct place, so it builds a JSON manifest, and then it goes to my Balena and it does the conversion. So new syntax goes to old syntax, and now we should be ready to call bitbake directly and build util Linux, and let's see what happens. And here is the waiting time again, which makes that if you want to develop the OS, you need a lot of patience or trips to get. Okay, so that seemed to work.
And what do you do on these times where you are compiling or?
So typically, if you're in the zone, you are able to multitask. So I typically leave something compiling and work on something else. So you have multiple of these multi-screens going on at the same time.
Okay.
You need to be very, very focused for that. Some other times you just go for a cup of tea or coffee. So
yeah, I think it was as well on our internal chat on FlowDoc, there was a question as well. I think it was Thomas. He was asking, hey, what do you do when you do a Balena push? And it takes, like, it's a big image. What do you do? No? And it was funny to read answers from people. Yeah, if you are here on the chat, feel free to let us know what you do. Yeah, when you do Balena push, or I don't know, or whatever that it takes. If you compile whatever or something, let us know on the chat, please.
So one of the things I mentioned I wanted to do is after it finished building, I want to check its contents to make sure that it has the fine round utility that we want. So that's what I'm trying to do now. Okay, why is that? Okay. So I think I had configured. So because I'm using the remove work. Oh, I know what happens. So it's because I have rerun Varis. I thought it would respect my local.conf, but apparently it didn't. So if you remember, I told it to remove the working object, so it empties the folder, and I want to have a look at the contents. So I have to make an exception for that. I have a snippet somewhere I can use. So
Okay, while you do that, maybe, yeah, we have been 3 hours here live on this release party, so maybe it's time to wrap up a bit what we are doing. What do you think? And what's the situation? So let me put again the milestones here. So if you haven't been here and you're new, welcome. This is release party number 7. We are releasing balenaOS Secure Boot and full disk encryption for device types x86, 64 bits with a secure element, the TPM 2.0. We are going to cover about TPMs at some point during these hours, I'm sure. And probably we are going to cover as well different architectures for secure boot and full disk encryption. But yeah, during the last 3 hours, we have been trying to update MetaBalena. There are different pull requests done during the last days by the balenaOS team, and we were checking one by one all the pull requests and yeah, sending them to our continuous integration tool and to testbot to check that everything was
One of the
okay.
PRs got merged.
Woohoo,
Yeah,
party.
wow, cool.
Release party, really.
This is how people have fun.
Exactly. So first PR.
Yes, the other one is running. I've rebased it in the background, and it's already building and testing. So
Okay,
might get through shortly.
So okay, so from 10 PRs, we have one already accepted. We are doing the second, and then we found a problem, and Alex is trying to solve these. I'm not sure I can explain technically speaking what Alex is doing. So I think that the version of the Yocto from a device or from a maybe you can go and explain technically.
So we have different Yocto versions for different device types. We update them from time to time. So we kind of our preferred situation would be where they are all in the same Yocto version and it is the latest, but that's not always possible. Some device types have BSPs which are not compatible with newer Yocto releases. So we've hit a problem with one of those device types, the TS4900, which is based on the Sumo Yocto version. And we've added a dependency to a recipe that old version of Yocto doesn't like. So we are going to append the Sumo layer to fix that. I was in the process of building the util Linux package for Sumo and just verifying that the FindMount utility is part of the build. So I've done that. So if you see this screen in the bottom left, so I've browsed into the working folder for the util Linux package, which is all the way down in the build temp work Cortex A9 blah blah util Linux, and I've got into the image folder, which is where the contents of the build package are, and I've done a find for FindMount, and there we have it, user bin FindMount. So what that says is, okay, if I change that util Linux FindMount, which Sumo doesn't understand, by just util Linux, the FindMount utility will also be included. And the patch that I made is just add. We can show it. We can hit show here. So we on the Sumo part of MetaBalena, we already had a append file for util Linux, and on that file, I'm just overriding that runtime dependency to have util Linux instead of the FindMount version of it. And that should work. So all that I need to do now is to actually bitbake a Balena image. see what happens. So that again is going to require us waiting. Oh, it's not Balena image, it's resin image for this. What is it that I need to build? Okay, let me. Speaking and working is not one of my strengths, so Balena image. I was using the wrong place, I guess, and I didn't pass a machine.
So Alex, should we move to Michal and he can show the last minute on Jenkins?
Okay,
What do you
yeah,
think?
because I still
Makes
have
sense?
legit Linux find mount not found. I don't understand why, so I'll have to understand why.
Okay. Does it work for you, Michal? That we get into your
Yeah,
screen?
sure.
Yes. So should I share your screen?
Yeah, bring it up.
All right. So we have here
So if I go to TPM 2 tools, you can see it got merged. All the checks,
Awesome.
if I unwrap them somewhere here.
Cool. Good job.
I can't. There was a way to show them. Oh, here they are. No. Okay. Anyway, the checks passed. We did not force merge anything. It really, the job in Jenkins passed. So in the meantime, I went to the peak driver, rebased it, and it's running a build. So let's see how it's doing. 17 minutes into it. So yeah,
usually how long it takes? Like 30, 40 minutes?
Interesting. I was expecting some of them would be already completed, but apparently that's not the case. So yeah, we'll see.
I have somebody ringing my door, so I'll be 5 minutes away.
Sure, no problem. See you in a bit.
So yeah, the one before took like 30 or 40 minutes to build, and the first ones were done after 10 minutes.
Beeple is telling you to click view details and then to
in
find
GitHub, right?
Yeah,
It
exactly.
Was,
and to find the test that run on the PR. So go to the PR.
So this one will be closed. Oh, here. Okay. Yeah, that's. The text is unusually big for me. I cannot orient on the page. Okay. So yeah, you can see the tests. Passed.
Oh, nice. Cool. Beeple, we would like to have you here live to talk about continuous integration and continuous deployment on Balena.
How did it fail?
Again?
It failed the job, and I need to see why. It goes 134. That's abort, I believe. So something killed it. Some nodes might be overloaded, to be honest. Okay, so another demonstration of our automation. If a thing like this happens, and what killed the job was not something failing. There was no error. Some browsers died with exit code 134, which is actually -6 when you overflow the 8-bit integer. And -6 means signal number 6, which is abort. So either the operating system killed it, or it did something it was not supposed to do, or there may be corruption somewhere. We don't know.
Okay.
It also happens when the Jenkins nodes are overloaded. So the first thing you do, you just retry, and if it fails in the same place with the same error, then you really start to debug it. So I was pinging Balena CI before, but our friend Jenkins has his own account, so I can actually ping Jenkins and ask it politely to retest this.
Always ask nicely.
Yeah. And he's not as fast as Balena CI, so he might take a minute or two to notice the ping. But eventually, the build will be restarted. We're gonna see it here.
Okay.
So we can see live how long it's gonna take. I'm just quickly gonna check on the dashboard how much tasks are running. No, they're all idle. Like not all, but most of them. So looks like we might have a chance of just having it succeed after restart. So we're like halfway through the stream. I think one way we can take out of it right at this point is that we really need to work on Jenkins.
What else can you do at this point?
To share context, it was not this slow when I joined the company, but as we kept adding more and more features and more automation, we just did not scale it, and that's why this happens. But it's very good that it. You see, I would never. I have no idea what the TS4900 is. I would never know the build actually fails and that I broke it without Jenkins doing this. So it's very good that it's. Oh yeah, it's already restarted.
I just started. Okay, good.
So it's good
at you ask it nicely. So
yeah, exactly. So it's very good that we do these builds. We just need to scale them up a bit.
Okay, so this will take some minutes, right?
Yeah, we can waffle. Do you have questions? Or do we have people around? So he can
I don't know. I ping him
and,
on FlowDoc. Let's see if he can join us. It starts to be kind of late in India, so I'm not sure. It's like 7 p.m. there. Yeah, I have I don't know if you have to work or you can talk.
I can talk probably. If I work, there's nobody to talk, so let's do that.
No, maybe I will try to get someone else here on the stream.
Hi guys, I'm back.
Hey Alex, how's your sumo?
So found a second place where we have introduced that dependency. I was trying to find out. So yeah, I'm still working on it. Need a bit more time before sharing my screen to find out what's going on.
Sorry, I was mute. I'm trying to invite people here. So
there's been a little uptake. I've also pinged the OS team. I mean, half of it is not on this time zone anyway, so maybe they are.
So how is the OS team distributed all around the world, Alex?
So we have people in the US, we have Canadians, and then we have Europeans. I guess the majority of the team is in Europe, so we have people in Romania. We have people. Let me think.
This is the devices team, right?
I was thinking, yeah, I was trying to remember Sahari, where he's
Bulgaria.
based. Bulgaria, okay.
Yeah.
So yeah, Sahari, he's in charge of the network manager, right?
Yes, networking in general.
Well, yeah, more things, yeah.
Yeah, we've got UK, we've got Germany. At this moment, I'm in the Czech Republic, even though my flag says Slovakia. But yeah. Then yeah, Canada, US, Brazil. So we're really distributed around the world.
Cool. I don't have a lot of questions if we don't want to get into more specific things like TPMs or.
I think we can discuss the TPMs. It's like
Yes.
Quick talk.
I was so upset that I have these on my table, on my desk. It's Advantech UTX 3115. It's interesting that this is a sample. This is from an old project I used to do in the past, before Balena, to connect cars to the internet. And this, it's supposed to be one of the devices that it's on board in a car. And yeah, I was so upset that it has a TPM at the 1.2.
So basically, with the TPM, there's two revisions. There's 1.2, which is older. It has less functionality. It's not it's not like completely broken or anything. It just does not have all the functionality that modern systems need. So the original purpose of the TPM is not disk encryption. It's actually playing copyrighted video. So it's optimized for what they call remote attestation, that a remote server is able to verify that you download their content only on allowed devices. And so they do that by storing some secret in the TPM that only the device has, and only the device is able to like decrypt the DRM protected video. But yeah, since then the use case is expanded, obviously, and while the TPM 1.2 is somehow usable with Linux, there are some DIY guides over the internet how to make it work, and you can certainly like set it up. There's we chose to start with TPM 2.0 simply because that's what the modern hardware has, and it's much better supported in Linux file system. So the tooling is not great for either, but the TPM2 at least has some user space utilities that you can use to talk to it. The TPM1 is mostly controlled using a mixture of talking directly to the device and inspecting it through some sysfs fields or something like that. So it's not ideal. And unfortunately, the two standards are completely incompatible. Like the API is completely different. So anything we do is not reusable. We would need a separate TPM 1.2 control plugin once we refactor it into plugins. And that gives me a very vague transition to the ARM world, where the situation is even worse, where there are boards that have like security chips. They're not TPM. TPM is basically a standardized device that is found on the Intel things. I don't know. It has an interface similar to SPI, which is found on many embedded devices, but it's not the same. So I am not sure. It might be pluggable to ARM devices, but I'm not sure how usable that would be. So in ARM, there are many different security chips that you can buy and plug into your device. One of the problems that this has is that if the device is like pluggable, when you, as an attacker, when you get physical access of the device, you get it with the dongle. You can just put the TPM chip out and plug it into your device. So it has a very limited way of authenticating the device it's been plugged to. and even if it has, you can plug something in between and just listen on the bus and replay the communication. So for it to work most reliably, you would need an embedded either TPM or security chip. And we know there are ARM devices that can do that. The IMX family in particular has this programmable, or they have one-time programmable storage where you can pre-flash the keys, burn some fuses in the CPU, and after that the CPU will only boot signed software, and there's no way to revert it. So even if you get physical control of the hardware, you can either use it as this or destroy it. There's no way of ever rolling it back and running your software. So that's one of the candidates we would be exploring. We also know there's something available for the Jetsons, but we have not dug into that deeper. And we know there's some third-party companies that offer dongles or dongles combined with their services. So we eventually want to evaluate them, at least to see how they work. But yeah, as for now, we only were focusing on Intel and just making sure we don't close any doors while implementing this. And I think we're going to be easily extensible to the ARM world. It's just about picking particular technology that we're going to start with and expand from that.
That's super interesting. Actually, yeah, I have a lot extensive experience with secure elements, but yeah, on the Helium project, the devices, the LoRa concentrators need to bring a secure element to have the blockchain keys. So yeah, I'm not sure, how this can be compatible with,
yes, exactly.
with what we are doing.
So the API offers a lot of functionalities. So some of it is basically a safe storage, which most TPMs implement, but not all of them, as we found out during development of this project.
Sorry.
They usually have a cryptographic API and a random number generator, so you can use that. And they have some cryptographic capabilities, like you can have them generate a key pair, and they will only ever expose the public key to you. So you can perform cryptographic operations using the TPM, but you have to have the TPM connected to your system, and you have to be authenticated to it in order for it to work. So yeah, that's that depends on which functionalities the TPM actually implements, and based on that, you can say which functionalities you can implement into your OS.
Interesting. So at the end, if a customer comes with a big fleet and says, I need to have a secure boot and full disk encryption, and I have this secure element, right? We would be able to maybe make it running.
We would need to check it whether it has all the API we need. It's very minimal at this point. We need three things. We need it to have a random number generator, though we might drop that. We only use that to generate really random passphrase for the Lux device at this point. Though it might need it internally. It's very likely that they will have it because they need it internally. And the other functionality we use is generate a key pair and have them encrypt the passphrase. So that's one thing I might touch. We don't store the passphrase for Lux in the TPM because of the thing I was mentioning. Sometimes the TPM does not have the NVRAM storage for user data, or it reports it has it, but the size is 0 or something like that. There are some corner cases. So what we do, we generate the passphrase. We generate a key pair within the TPM, and we ask the TPM to encrypt and decrypt the passphrase as we need. So to successfully unlock the the storage, we need the TPM. We need it authenticated to the OS, and we need it to have the key stored into it during flashing. That's how it works.
We have a question on the chat, and later I will introduce Vipul and Rafa. But Christian is asking, you talk about where the private keys are stored. Does it mean that the device needs to be online during the first boot, or they can be stored on the TPM?
No, the TPM does all the work. It does not need anything else. We use like TPM random number generator to get a passphrase, and then we use the TPM. So the calls that we use is like get random number for the passphrase, then create a key pair. What it gives you is pointer to the TPM somewhere into its internal storage that says the key is stored here. It's not like secret information because you can always loop through all the slots. It's just eases the access for you. And then we have the passphrase, we have the key pair. So we ask the TPM encrypt this passphrase with this key pair, and it will give you the bytes that we can then safely store plain text into the device, because only the TPM on the device can then decrypt it. I hope that answered the question. If not, please ask further.
Yeah, exactly. Feel free to ask whatever question you have. Let me put this again here on the... Vipul, how are you? Feel free to introduce yourself if you can.
Hey, Mark. Hi. I just had an electricity failure as Anuj as well. I think those are getting surprisingly common. Probably something about a release party happening and the electricity board knowing about.
Oh my God.
But
is this very normal in India, or?
In the place where I live, like in this, like quite close to the center, the electricity cuts don't happen that much, and usually everyone has generators or inverters, so usually it doesn't affect that much. Even when the electricity goes out, I made sure the modem is on the router, so definitely there is not an issue with the internet going off at a weird moment. But yes, I was out to run an errand, and sorry for joining the party late, but I've been listening in on the stream, and I was messaging on the comments as well that I was just coming here in 10 minutes, and yeah, maybe it's a good time to do a recap for the stream. Sure. I see we are running a three like it has been running for 3 hours 30 minutes, so maybe a good recap at this point is nice.
Yes, of course. Yeah. Should we do? Should I lead that recap? All right. So we have been doing this release party for 3 hours and 30 minutes already. It's the 7th release party, and we are trying to release balenaOS Secure Boot and full disk encryption for x86 64-bit devices with TPM 2.0. At this moment, one PR has been accepted already, and I'm not sure which one it's already running. And I think Alex is as well trying to solve another issue in parallel. And that's more or less well, I don't know, Alex and Michal, feel free to jump and get more specifics on where we are right now.
I mean, that's fine. Something we could start doing also, which we have to, is we have to review the manual test cases we have, and then we thought we would start doing some automation of those to show how that actually looks like. We also have to finish the PR reviews, so I don't know if anybody else from the OS team joined, so that we can continue with that. I'm close to finishing I'm checking one last thing, and then I'll explain what I've been doing.
Michal,
if you want to explain the situation on Jenkins and the pull requests.
The situation with Jenkins is that, yeah, we've been waiting for Jenkins for most of the time, basically for testbot. Why we have this is that on each PR, we want to make sure the system is bootable at least on one device, which is the Raspberry Pi 4 at this moment. We are considering starting to force merge some PRs, at least the smaller ones, because this feature does not really affect the Pi 4, so it's very unlikely that we're gonna break it. But yeah, we went through. We've had 10 PRs. One of them is merged. One of them is building. Some of them are basically pre-approved, and we have found a bug in one, which Alex is working on. And yeah, that's the situation. We still got a few to go through.
I have a question for you, Michal, if you don't mind. Let me share my screen. Because I had fixed my the problem we had, and now the build is failing in a different way. Are you guys seeing my screen?
We are.
Yeah,
if you can make it a bit bigger.
Bigger. Okay.
Yes.
Okay, so there's something I realized. This is the PR I'm looking at. Okay. I think it's the correct one. Is this the one that has the KSEC? No, it's not this one. Yes, this is the one that has the KSEC. Okay. So on the recipe, here you install a script called 92KSEC. Okay. But down here we include 91KSEC on the files, and it's complaining about that. That's a mistake, I guess.
Okay, that's a mistake, definitely.
Okay, I'll address that also. Just wanted to check that I wasn't missing anything. So it should be.
It's very interesting that it did not come up earlier.
Yeah, I was wondering that too. I don't completely understand why it didn't fail for other machines. Strange.
Yeah. Okay, that's yeah. I don't know.
Okay, so I'll be sharing that. So do you want me to force push over your branch with a new PR?
Sure, go ahead.
Okay.
Mark,
maybe
if you're trying
I'll
to
be
talk,
working on
you're
this.
mute.
Oh, sorry, I'm mute. Okay.
Yeah, what we can go for is like maybe Michael and I can talk through the testing cases that we have for test lodge, and then right now, like automating them could be a task that we could take up, where we might not be able to run the test because the QEMU worker situation right now. But maybe we can talk. We can tell the people like how we are going to test and automate this.
So yeah, I guess Mark, bring back my browser. I'll open test lodge. And while I'm looking for it, people could say a sentence or two about what we're using it for.
Indeed. So test lodge is our manual OS test automation, I would say, dashboard at this point, because all the tests that we are writing in test lodge is basically plain text. These are instructions that the testers can follow, and as they can follow instruction, they have an expected outcome that they need to get at the end of the test. And if they get that outcome, then they can put the test as paused for that particular scenario. Here, as Mikhail is showing, we have 6 test cases, and then you have for those 6 test cases, you have sub cases about when configured for Balena OS Secure Boot and no other OS is bootable. So we have basically a true test, a false test, a test that would sort of break something, see if you can recover. And we are thinking about all the scenarios that can happen in real life and test those when we are testing. So at this point in test lodge, we have instructions, as you can see here. This is a happy path scenario where we are ensuring we start off with a very simple but core mission about what this test is going to be all about, and it's going to be testing this one single thing. And then you have test steps, and then you have an expected result, and usually all tests go like that. With test lodge, we have it's basically a dashboard with a lot of tests being sort of stuck together, and then you can use that dashboard to sort of run manual testing on whatever software that you use or something like that. So this is what we use right now, and then we'll talk more about how we are automating this.
Mm-hmm. So do you want to go through the test cases and
Oh yeah, like you can take this like about what have you planned for, what should we be testing,
Mhm.
or things like that. So I see this is the happy case.
Yeah, sorry. So yeah, this is the happy path. This basically ensures that if you configure everything properly, then the feature is enabled. So how it works, we were mentioning that before. It's going to be the same image as the regular generic x86-64 device type that you can download from the dashboard. Enabling the feature will be triggered by you setting up Secure Boot in UEFI setup. So if you burn the 3 necessary keys, which are the platform key, key exchange key, and database, if you set it up in BIOS and turn on Secure Boot, then our Flasher image will be bootable because it's signed with those keys. And it will automatically detect that Secure Boot is on, and it will turn full disk encryption on as well. So this is just a simplified standard procedure for our provisioning. So after UEFI setup, we somehow burn Flasher to a USB drive, boot it, let it provision the device, reboot, and it should come up. And so what should happen? Flasher must run. It must not get into an error like unsigned system or anything like that. It should output no errors. The newly provisioned device would register with Balena Cloud. When you check that the mounted partitions, they must be encrypted. So under Linux, they would come up either as device mapper devices, which are like the FDM something, or they can come up as their aliases based on which UDEF rule executes first. So they would be like def mapper looks something. Either way, it's very explicit that this is not like def SDA or def MMC BLK for the SD card, and it's the encrypted device. And at the same time, we want to ensure that Secure Boot is actually enabled. So Secure Boot variable value should be 1, and setup mode, which makes it possible to rewrite the keys, must be disabled. So these two things ensure that Secure Boot is up and running. So that's the happy path. Any questions to that?
None from my like one from my side is where when we are sort of setting up the Secure Boot, like in the second step of test steps, are we thinking about like this? Is this a step that people have to do manually? Like, is it a one-time thing?
Yes, it's only before provisioning. Like right before provisioning, you have to set it up. There's 2 implementations, completely depending on the BIOS vendor. So you either have to like load the keys from, say, a USB drive within the setup program in UEFI, or you can only put it into the setup mode, actually the same one that we check here, which makes the keys writable from the operating system, like user space. So if the feature is not there yet, but for these motherboards, we plan to add the feature into Flasher. Like when Flasher detects that Secure Boot is enabled and setup mode is enabled at the same time, it would write the keys and enter the secure mode as well. So yeah, and for when it comes to automation, this is why we want the QEMU workers in Leviathan and in testbot, because for this we actually need to program the BIOS, and it's not impossible, but it's not very trivial to do on physical hardware. Like we would need some keyboard emulators, or
keyboard
we
and the
would need
mouse.
chip clips on the NVRAM of some motherboard.
Oh yeah.
And none of this
Yes.
very practical. So if we have QEMU, we can influence the BIOS configuration from the outside. So that would help us a lot automating this.
Thank you. Yeah, that answers my question. I was also going for, like, just to sort of help the people who are listening in, is explain a little bit more about how, when you do the one-time configuration, how we make it work the next times around. So let's say you have configured your x86 device right now, which is the Intel NUC, and you have done this manual process that Miguel was just mentioning about going into the UEFI or the boot and turning on Secure Boot. After then, when you flash balenaOS the next time around, balenaOS, I think, checks that that property is turned on, and like the Secure Boot is turned on, and then it automatically understands, okay, this device is meant to be secure booted, so we will now encrypt the partitions and make it secure boot. And that's what I was going for. Yeah, this is how we are sort of going forward. So this actually reduces a lot of friction, because you have to do this process only once, and then that's it.
Yes, good.
And just to add on to it, like, this also helps a lot with hubs. So let's say you are updating you have a large fleet of Intel NUCs, or you have a large fleet of x86 devices in the field, and you you update your balenaOS, right, in the field. So you don't have to worry about the secure boot breaking. Your secure boot, like, even when you hop to it, it stays in place, which is
yes. So
yeah.
hub is sorry.
Yes, a little more about hub would be nice, but no worries.
So hub needs to make sure that the newly updated system has the signatures in place.
Right.
We have a very trivial hook to check for that, like a dumb one that just checks that any signature is in place. But we have plans to, like, improve it, to actually have it check before it starts switching to the new OS and reboots, to check that the newly updated OS will actually be bootable. Because if it's not, then none of our rollback mechanisms will trigger, because the one who will not allow going further is the firmware, and it's sooner than any of our code is executed. So for this, we really must make sure that at least the first stage bootloader is correctly signed and will be booted. That's where we can start our handling of errors.
And from an automation perspective, are we thinking about, like, this thing? Let's say we are thinking about a bad path, right? We hop an image. We already were in Secure Boot. Life was very good. And then we want to hop to the next image or the next upgraded balenaOS. And we sort of find out that the keys are not present. I guess the keys are the right word, where we sort of specify, okay, these partitions are not in the secure, like, are secure booted. Do we have a new flag? Like, do we have a new rollback flag for that, or we never reach that stage? We
we never reach
it never
that
boots
stage.
to that.
Like,
Yeah. Okay.
there's a hook at the end of hub which checks for the signature, and if it's not in place, it would abort the update and never reboot or never do anything.
Nice. So the hub doesn't take place, and then we roll back to the previous OS. So yeah, cool.
Yeah, you never even try the new version. You just abort the update.
Nice. Yeah.
Okay.
But regarding this, let's a little, like, if we talk about how we go about automating this, usually there are a lot of steps that we need to go through. Even before we start automating the test, is on our automation framework that we have, like with TestBot and Leviathan, we need to make sure our x86 device that we are trying to test on is already supported to the framework. Let's assume it is, and we just start with the steps, with the sort of the test steps that we have, and we chart our path towards creating a test suite for Secure Boot. In my mind, I would say, like, if we start with our first step is we look at the test steps in test logs as people have written here, and we try to form automation steps that would be resembling exactly what the user would do with their hands on the keyboards. We are basically resembling that in our framework as well. So if we are getting a flasher image of a generic x86, we will be getting that image when, for us, we will be getting that image. So let's say you're testing Balena OS, right? You have a new version of Balena OS. So when that new version of Balena OS builds through the Yocto releases that Mikhail was showing you on Jenkins, we get the image from there. So, okay, we have the first step. We do get the flasher image for the generic x86 board from the fresh Jenkins build. So it's still in the PR. It's right off with the new change or the new upgrade that's happening to Balena OS, and then we can test that image. And the second thing is setting up Secure Boot for UEFI. We had discussion. I think we were discussing this last like I think on Tuesday, about how we are going to do about this, because as Mikhail mentioned, this thing has to be manual, and in an automation suite where we want to automate everything, that thing just can't stay. Where we have an automation, like a manual step that you need to do it with Secure Boot. The reason behind why we can't do it easily is once you activate Secure Boot in the device through the UEFI, it will always boot in Secure Boot until you disable it manually. So that's what I mentioned, Mikhail, for like how we are going to be secure booted every time you flash a new image. This is how. When you have set Secure Boot in your UEFI, it will always boot in Secure Boot. So that way we are trying to solve it by using the QEMU worker, as Mikhail mentioned, is we'll be setting the Secure Boot in our tests in the UEFI every time we start a test. We have to figure that one out. Um, things are not easy as it sounds with testing, because we got lots of platforms that we support here, and we got lots of work that we do, and with the compatibility between devices. Ryan is here, and we are always talking about like how we can sort of make this easy for both the people who are writing the test, and then when it's running, as you can see right here, and when it runs on scale. Because I think I remember Mikhail mentioning that even the UEFI menus are different for some devices.
Yes, even for the same
So,
devices. Like
oh yeah,
if you update BIOS on the same NUC, the UI sometimes changes slightly. And if you have some like automated keyboard control or something like that, there might be a new tab somewhere, and then you're completely lost.
oh yeah.
So
And
yeah.
like code, when you write code or a set of instructions to sort of go automate a UI, people who might have been watching the stream and they have been doing E2E testing as well, automating a dashboard is hard enough. Like automating an OS level BIOS or menu is quite hard, because things could change and then you don't know what's going on, and it takes a lot of time to sort of fix that process again to make the test work. So that's why we are going with the QEMU worker, which is easier to um, configure, and then it's faster as well. So as the second step was, we will be setting up the Secure Boot. So we have a procedure, or we have at least a direction how we want to do that. The third is we will flash the flasher image to the external media, and maybe we'll probably explain, should we, what the flasher image is and then what comes after it, like the flashing process a little.
What do you mean exactly? Like
Oh, yes. As in, let's say it's an Intel NUC image or an generic x86 image. We have a flasher image that is burned into the external media. And then on the first boot, the flasher, the image inside it gets flashed onto the storage media, and
yes.
that process. So we can talk about how we automating that process.
Yeah, so I can give how it works with the flasher image.
Yes.
So,
I'll do the other part.
yeah. So basically, we have two ways
We
of.
have a PR for that. We have. Maybe it's worth to review the PR.
Oh, we do.
While we speak
nice.
about the flasher.
Okay. So I'll give the high level idea, and then we jump in what we need for this feature. So basically, from a very high level point of view, we have two kinds of images for Balena OS. One of them is flasher, and one of them is the raw image. The difference is that while devices like the Raspberry Pi need the image just directly flashed to an SD card on an external device and then plugged into the Pi and start it, the devices with an internal storage that is not easily removable, let's say a hard drive in a NUC or an embedded thing or eMMC drive on some board, you have to flash it while on the board. So for that, we have the flasher image, which is basically very similar to the regular Balena OS image, but instead of registering with the cloud and running the Docker, the Balena applications, it runs a tool surprisingly called Flasher, which has the raw image embedded in it. So we always build a raw image. The Flasher kind of sits on top of that. And how it works is Flasher boots on the device, initializes all the hardware, looks for the first available hard drive, and basically copies the operating system image into it. So Flasher usually is on USB stick or something like that. It may be an SD card. We've got devices that can boot off an SD card, flash an eMMC on board, and then boot off that. But it's an external media, so after you remove the media, the only bootable drive that remains on the device is the newly provisioned one. And yeah, that's how it works. So you don't need to write an SD card on your laptop or on your computer, or you need, obviously you need to write it with a flasher, but you don't flash the hard drive of the device directly, but you write it from a live system running on the device, and that is what helps us with this feature a lot, because we can do the tricks. We can pre-fill the keys if we are in setup mode. We can do the splitting of partitions that we were speaking about in the morning. And we can do some other tricks that we're going to go through as a part of the PR. So that's what Flasher is for. And from now, either people can tell how we automate that, or we can go through the PR and see what's necessary for Secure Boot.
Oh, we can see the PR, but like I think this is a good point to sort of mention is, as we sort of heard how this, like the flasher is flashing the non-flasher image onto the storage media. It's very interesting to sort of understand how we go on about automating this, because when you do it through let's say you're using this this tool, low-key tool that we have called Etcher, and you use that to flash something and flash the storage media with the flasher image that you have, you're doing a bit of manual steps, right? And it would be easier, or sort of it would be interesting to understand like how we do it in an all automated environment, because if you just count your steps, or how we do it in the testbot team is like we count how many steps are there that your hands do, like literally from plugging in the memory card and then plugging it back, plugging it out, to running Etcher, flashing the memory card, then putting that memory card into the Intel NUC or whatever x86 device you have, and then powering it on, and then powering it off. That is a long list of steps that you have to do to actually
the more
flash.
devices you flash, the more you realize that.
Yeah, and we flash a lot of devices. You can sort of count us on that. We created Etcher Pro for something, and that's a shameless plug right there. But we do flash a lot of devices. So when we talk about automating them, it's a really interesting process. And maybe Ryan can get us through with that one about how we do Intel NUCs flashing, or just any flasher images flashing.
Well, I mean, it depends on the device, because different devices can have different flashing procedures. They might need a button press. They might need a jumper set to a certain configuration. For the NUC, we actually flash it with the test bot by plugging the SD mux that I showed earlier into an SD to USB adapter and plugging that into the NUC slot. And then before we kind of deploy the NUC to the rig, we go into the BIOS and set it to boot from USB first if present. And we also change a setting to make the NUC power on automatically after power failure. And basically what we do is we flash the SD card, which is connected to the NUC via the USB thing. We toggle it to the NUC, power on the NUC, and the NUC boots then from the flasher image that's just been flashed to the SD card. And then from the test bot, we monitor the NUC to wait until it's turned off. And then when it's turned off, we take that as it's having flashed its internal storage. And then we toggle the USB stick away and power it on again. And because we've set the BIOS to power on after power failure, just reapplying the power lets the NUC turn on again without having to push the button. It works well mostly. There's a few niggles though. Sometimes when you just pull the plug, from these x86 boxes, it just goes crazy when you try to boot it up again.
Yep.
So I have a question, Brian. Have we looked into automating the BIOS configuration?
No, not yet. No.
Because I'm just looking at the test we have here. So we would have, if we want to automate this, we'd have to automate the entering secure boot mode. Like I'm thinking you boot into this BIOS, and then you would have to simulate, you have to know what keys to press. You could probably simulate those via some type of USB.
Yeah.
I mean, type of thing.
In an ideal world, we'd be able to, kind of like fake the key presses to go to where we want to go in the BIOS and change the setting and just hope. I mean, we can just make sure we only deploy test devices that have the same BIOS structure, maybe.
The alternative to that is to flag, so to configure the NUCs with secure boot and to flag them differently, so that the test bot knows, okay, for this test I need to run on this device.
Yeah, true. Is there a way to change the BIOS without going through that kind of like graphical interface that you usually see? Right, unless I'm like usually, like if I wanted to configure a NUC's BIOS, I have to power it on.
That's a good
F2.
question, Michal. So if we boot, so we said that these NUCs, they already configured to boot from USB. So can we actually boot into a UEFI application of sorts that is actually able to modify the BIOS configuration? So
like we could use a file to do it
on.
Yeah.
Something that would make it easier to configure. That would be nice.
So we would be able to do that, I believe. But it is very likely to break the TPM signature chain, and it would not unlock the partition if it's done after provisioning.
No, I think this is
if we do it like before the test to reset something,
so this
probably
would be
okay.
So
no, this is before.
Yeah, so just before the test runs, so the suite is running and it gets to a point where it knows it has to run the secure boot test. So for that test, the test framework has to load special application that will configure the BIOS how we want, and then boot again.
Okay.
Yeah, that's a test to the it's a precursor
I'm
to the.
speaking in my mind a bit now, but I'm not 100% sure you can toggle secure boot on and off programmatically, but we could build an EFI application that we sign with our keys, testing keys or whatever, and boot it prior to the test, because the setup program is also an EFI application.
And
so
this
we could have something like a batch thing that would reset the BIOS to to default settings. It's something that needs to be explored. I have no idea whether that would work for 100% cases.
We don't want to reset. We want. So can you set the secure mode with UEFI update bar, for example, or something like that?
Yeah, I'm not sure. We will have to try. I would be surprised, to be honest, but I'm not saying it's possible.
Okay.
Right.
Yeah. So that's something we have to explore before we can actually start automating this test in particular. Yeah.
Yep.
Yeah,
And
to,
On
to
physical
me,
hardware, like
if
on
we
Qemu,
can,
we're okay.
okay, yeah, because yeah, I feel like if we're able to, somehow inject the BIOS configuration that we want,
I mean,
without having a keyboard.
The engineer alternative is a chip clip over the chip that holds the data, but I would like to avoid that as much as we can.
Tampering is not an option. But as you can see, like for folks listening into this, to the process of like both how the flasher images run and then how do we automate them, I think it's extremely good to sort of see the part about what Ryan mentioned. Like I was mentally calculating what Ryan was saying, and I counted 14 steps that we did. That we automated, like from powering on to powering off to detecting it powered down to detecting it flash to detecting. We are like testport supplies the voltage as well, so we can control the power on and the power off of the NUC, but it's a long process to only just do flashing, and you have to, like, the instructions that you provide testport to flash has to be reliable and also scalable enough that it can do it 1000 times without breaking. And that's the scale sort of we play with. Like I said, we flash quite a lot of times, and it has to be each time it has to be perfect, because if you don't flash it correctly, then you can't test correctly.
Some devices are easier to flash once you've provisioned it once with Balena OS. For example, the BeagleBone. I'm not sure why. I don't know the details, but if you have like a fresh BeagleBone that's never had Balena OS on it, to provision it, you have to hold a button down, and it will then that like triggers the process of trying to boot from the SD card the flasher image. Whereas if you flashed it with Balena OS once, then you don't have to do the button press anymore. I think we must load some custom bootloader or something. Yeah,
the flashing stories has been endless. Like each device is a different challenge. Like with power requirements or cables that you need to plug in, or how do you deliver the power. I think one of the another one is Jetson TX2s, which are like, I haven't seen one, like I don't have one, but I think they're as big as a motherboard, to be honest. And you have to power, like, well, how we are thinking about testing or getting Jetson TX2 boards supported, or powering them through a GPIO pin, triggering the power on and off from it, and passively powering them. So we don't control the power, but we control their on and off scenario. But yeah, that's something that is under development, and we have to still think about that. And yeah, so that's the third step. Literally, flashing is a major part of getting the device online and then starting to run tests on it. Because when the device is online and when it's on Balena Cloud or when it's reachable through the SSH, then it's, I wouldn't say anything is easy, but it's still easier than that. You can start to run tests on it, see where you go, see what fails, see what you need to change in your test suite, or sort of tweak it a little to get the test through. And for this one, I think what we are thinking about, since this is a happy path, now when you have booted into the actual image, oh yeah, I think Alex was sort of mentioning something as well. I can check it out, but yeah, this may be a way to do it. You do see what I'm seeing, right?
Yeah.
Okay, but yeah, this is like the expected result that we have is what we are trying to prove, and these are basically our test cases. So test steps are what you can call the way to provision the device and get it online, or how do we want it online, in which state. Test steps could also include like Balena push this container, or put this DT overlay, And then you have these expected results. These are the actual test cases. So our expected results include like flash runs with Secure Boot enabled, no errors during flashing, no errors during the newly provisioned device registered with Balena Cloud, and so on and so forth. These become our test cases where we are checking either the file system, or we are checking specific files, we are checking specific behaviors of the device to see if our test is indeed successful, if the action that we are performing or testing is indeed successful. So that's usually how the automation of one test scenario goes, and we have 6 of them. Maybe we can run through quickly like the other 5 that you have, Mika, for us.
Yeah, they're similar. So
There's something I wanted to say. That there's a comment by Alex about how we could simulate a keyword with a Raspberry Pi. I think it's worth to mention that for me, that's a feature of testbots. So I mean, this cannot be the only test we have where we actually need to input keyword. So I think it could be quite useful to actually implement this so that you could plug a USB to a DUT and just simulate keyboard pressing for different things. Like, okay, what happens if I Control C? Do I get into the boot, the U-boot shell or the grub shell, or that type of tests? They're probably
I
something
think
we don't
even
have.
maybe Anton has built this already for something, but it's definitely part of the automation kit for sure.
Yeah. So that's the type of thing we need for the secure boot configuration in the BIOS.
Yeah, Ryan, do we have anything like that?
We don't, but now you've mentioned Anton, I remember he might have done something for it a while back with the physical workers. I'll ask him.
Yeah, but I mean, this is so easy. We should just do it. It's one day. It's a 1-day project. No, like really, not seriously, not just like really, truly, yeah. Yeah, I think this is it's a very simple tool, and it's very powerful. So, pretty good idea to do.
Okay. Should we do a summary of where we are?
Yeah, let's
yes,
do it.
please. All yours, Alex.
Okay. So we've been working through PRs this morning. We are still on the first milestone, which is getting PRs meshed in MetaBalena. We've also done some live reviews of the PRs, and we have the Jenkins build server building them. It's a slow process, so we have to build first of all, which it takes around 20 minutes, 25 minutes to build all the different devices we have, even though we are using shared state caches. And then we have to run the
test. Do we know
so
why it takes 20 minutes? Like, I mean, with shared state caches, it should just take the time for the new thing, right?
It depends on the different device types. In some of them, it's as quick as 7 minutes. Some of them, it takes up to 25 minutes. I don't understand the differences, why that's the case. I don't have an answer.
Okay, but for I mean, there's more questions here. Let's do the review, but I do want to keep talking about the build speeds afterwards.
Okay. So yeah, we also had the Raspberry Pi 4 test running. I've actually modified the checks now so that we don't have that running anymore, because it doesn't apply to the feature set we are working on. We said we wanted to have a virtual QEMU device that we could use to run, but unfortunately we haven't been on time with the changes, so we don't have a virtual device to add to testbot at this time. So I hope that for the time we have
next Thursday's release party, huh?
The next release party, maybe, yeah. So for the time we have all the PRs, they will not run any test in testbot at all. So the only thing we would need was to build. We've also we had a PR that actually had a failure building for one of our older device types, the TS4900. So I've been working on a fix for that.
I think we can actually stop supporting the TS4900. The customer that this was for has since stopped existing, I think.
Yeah, that would be good because it's on a very old Yocto release. So that's probably something we need to discuss with the customer success team. Let me share my screen. Okay, so
wait. I think I tweeted this out, so there's going to be some viewers as well. So let me zoom out a little bit. So we are building Secure Boot for the Intel NUC, right? So when we're done, there's going to be a version of Intel NUC that, the Intel NUC, as you can download it from our dashboard, right? The image will support Secure Boot, which means what?
So
which means
in practice, it's the generic x86, but that's technically probably.
Okay.
So
no, that's good. That's a good clarification.
The image would be able to boot either with a disk encrypted or as it was before. So the trigger is if you set up BIOS, which you have to do mostly manually. If you set it up for Secure Boot and enable it and flash her while running the text that is running a Secure Boot, it will also encrypt the hard drive. If flash detects that Secure Boot is disabled, then it would provision as it would without a feature.
So the idea is you set up the BIOS, and then you flash it, and then the flasher will look at the BIOS setting to do the right thing.
Yes.
Correct. We cannot do a host OS update from a non-encrypted one to unencrypted. It has to be reflashing.
Yeah. No, this was part of the original spec. I remember that. Yeah. So yeah, it's you set it on its course before it leaves your factory, and then it can keep doing whatever it is you asked it to do. Cool.
Yeah.
Okay, so that's what we're building, and then what's the first milestone we're aiming for?
We have 9 PRs open in Balena. We've reviewed 5. We've merged 1. We had 1 build failure, which we fixed online, and I was just going to speak about it. And that's the status. The rest of the time, we've been speaking about the different aspects of how the OS team works, including how we test and test board and automated tests and all different things and aspects of the OS team work.
Cool. So back to the build speeds. Did we? Forget the build speeds for the moment. Did we learn anything in this process so far that we are going to take to improve our process in general?
Well, we knew that we have some bottleneck when doing the merge PRs into Balena. We knew we had a path forward, which is a virtual QEMU. This has been a task part of the testing project that we are working on. So if we had that in place, I think the situation would be much better. That's something that has become obvious in this.
Next Thursday, release party. That's simple. Next week, same time, same place. Let's do it.
What's the status with that, Ryan? Maybe it's worth to give an overview.
Yeah, you can run the tests that we have, but some of the tests were failing just because the QEMU environment was different, and since yesterday, when we started trying to get this thing ready for today, it's just been a process of just ironing out those problems.
Are we still working on that?
Yeah, as of this morning, I tried to get it finished in time for this.
Wait. So this Camu thing, right?
Yeah.
Is it what part of the stack does it belong to?
So it's in the Leviathan stack. So what it does is it's a container that has an interface that's the same as the test bots. So the tests can talk to it, and it spawns a QEMU device with the image you give it.
But you're
use
saying
the
it
same
works,
test.
but the tests have failed? The tests were failing?
So the QEMU device appears. You can run some tests on it, and a few of the tests fail because of one thing or another. Like, for example, there were some connectivity ones that failed. Connectivity ones that failed because they were looking for like an interface with the wrong name. The HUP tests, there was some failure there that I haven't debugged yet.
Okay, so the question is it a problem with the tests or is it a problem with the setup?
It's a good question.
Well, it's the question because until we know that, we don't know if we don't know who should be working on it for one, and for another, we don't know if the feature is actually there or not, right? Like when you fix the other problems, did you? I mean, I don't know. I think you probably know the answer to this, and we should probably just just blurt it out. Are you fixing the tests, or are you fixing the camera support in Leviathan? Where are you focusing on?
So it was modifying the tests so that they'll work with the QEMU worker.
Okay, so OS team, this is your job. Ryan, please release Camu. Release the feature. The feature is there. The tests are not tuned for it, which is not your concern really. It is the user's concern. You're building the platform to do this. It's not your job to make the test work, right?
Okay.
I mean, unless the feature needs work, but if the feature is working and you're retrofitting the tests to the feature, that's for the user to do, really, which is the other guys.
Yeah, I mean the task was started by the OS team, so it was Joseph working on that. It's only the last couple of days that we thought we needed more hands on it to see if we could make it on time for the release party. And that's when Brian got involved with the PR.
Yeah, but right, yeah. So, but Brian should not be working on the tests. That's just we're trying to create this dividing line so he can focus on things like keyboard support for the automation kit, or there's a lot of other things. And the thing with these tests is that anybody on the OS team can do this, right? Can work on this, I assume.
Yeah.
So Ryan is very precious, and there's only one of him. So really, anybody.
I'm not very precious, Alex.
You're precious to me, Ryan.
Thank you.
And
So let me rephrase to be sure I understand it correctly.
He's very valuable, not very precious. Fine, whatever. He's also kind of precious, but mostly valuable.
Oh.
So let me rephrase if I understand it correctly. So if Ryan releases the QEMU thing, the state would be we will have the test running and they will be failing on the QEMU devices, right?
No. There are two products here, right? One is the operating system and one is the automation kit with Leviathan included. Let's just add that to them. That. So the question is, question one, does Leviathan have the ability to run tests on a QEMU device? Mm-hmm. That's the feature that Ryan should be working on. Whether the OS's QEMU tests work or not is not Ryan's job. It's like saying our Balena customers can't use our product, and therefore we should go and fix their product. If there's a feature missing, we should fix it for us. If they need to adjust their product to work on Balena, that's their job.
But these are tests that are working fine on other, so it's going to depend on the type of failure. Yeah, because if it fails only on QEMU, is that because of the harness, the framework?
Well, but that's why my first question was like, where are the tests being made? Because if we release a new feature on NVIDIA, right, and somebody says, well, it doesn't work on the Raspberry Pi, It's like, yeah, it doesn't, because they're different devices. Like it's your job to differentiate between them, right? Like,
So
is
the tests that are
is
failing, what are they?
like
Yeah,
modem?
Balena.
Of course, modem. Because well, first of all, why does Meta Balena do modem testing? And B, yeah, it won't work on the camera. It doesn't have modems. So the question is to me, where are the fixes being made? If the fixes are being made on the on Camu, on Leviathan, then fine, this is Ryan's job. If the fixes are being made on the tests, then this is the user's job. In this case, you guys.
Yeah, that's
Agreed.
clear.
At the
So do
minute,
you?
though, I think because it was so fresh, the line was a little bit blurred. Like we trying to find
Look,
out what
I get it,
was.
but at the very least, you should be partnered with somebody, because that line that's blurred when it's your code now that's running on the customer's side, then it's going to come back to you again afterwards, right? So at the very least, it should be peer, coding situation where you have at least someone from the OS side working with you, because you should not be committing to. And I'm saying this loud. I know we've talked about it, but I want everybody else to hear about that from me. So I'm saying you should not be committing to, not committing at like making commits, but committing as in taking a commitment on the OS code base, even if that's the tests, right? Because this is not your code, and everybody on the OS team should be owning that code and not the automation kit side of things.
Yep.
Right.
Yep.
Okay. Should we do a review of
Yeah, let's keep going.
our PRs? What's the status, and then continue. We were doing two things. We had pending PRs to look at and review and explain, and then we were having a look at the manual testing and speaking about how would the automation of those look like.
Okay, I guess let's go further with the PRs. We can just bring them up, comment on them, and see. And then when we have them sorted out, we can jump back to the testing automation, I guess.
Yep.
So this one's probably not finished yet, though there's not much missing.
You know, with that thing we just saw there with all of the Octo builds, this is a stupid question. Why, you know, they all seem to take a different amount of time. What usually, like some of the BeagleBone takes 23 minutes, but then Raspberry Pi took 1 hour 11 and counting.
So
what usually makes the difference?
So my understanding is they're not all executed in parallel. So they all take roughly 20 minutes. So the one that would take 40 were queued behind the first one that took 20. The whole time is because they're spawned at the same moment, all of them.
It also depends on the contents. So, for example, if we PR a change that needs to rebuild the kernel, that means that it also has to rebuild the kernel modules, and they would have different number of kernel modules, each one of them. So, for example, if you rebuild the kernel, I would expect that the generic x86 will take much longer because it builds a lot of kernel modules, while some others they don't build. Now, if you don't rebuild the kernel, then they should be more equal. There might be some other packages, like I know, for example, that some of them they build more packages as part of the BSP than others, so they are not exactly equal. But it also depends on what the change is.
So, like in theory, if we had a builder like for every single one of these, so you could execute all in parallel, it would take like 20 to 25. It'd take like as long as the slowest one, I suppose.
Well, if you
It's not
build from
realistic,
scratch,
probably, right? To scale horizontally that much.
if you rebuild and haven't changed anything, then they should all take the same amount of time from cache, and it would be like 3, 4, 5 minutes, I guess. You just have to recreate the images, basically.
Okay.
But then it depends on the changes.
We need to investigate it though, because it does not take 5 minutes. It takes like 15 if you do no changes though.
Yeah, it does. It does like several images. Like it does the. So if it's a flash share, it does the raw image and then the flash image and the IntelliMFS image, but it only builds the last part of the image generation part, which is not cached, basically.
Like if I'm taking anything out of this, is that we need to look into that because it's just ridiculously slow.
It's quite crazy, isn't it? Like I remember trying one of these once, like locally, like to build one of these, and it took like 10 hours, like on my poor little laptop.
Well, in the long term, we are speaking about stop using Yocto to create the images and have something like Etcher build the images from some type of manifest description of the contents. So it depends where we want to put the time on, I guess.
Okay.
So
anything else?
How many of the PRs are building? How many do we have to review?
Well, it doesn't matter. You have to rebase every time you merge one. So.
Yeah, I know.
I was hoping like one thing that we learned about from this is if we can sort of improve that behavior about when you merge a PR and then you have to rebase, can we abort the tests that are running for that PR already? Because that adds up a lot of tests to the queue that don't have any results to report to. Because let's say you have 5 PRs that are running the tests. One of them gets approved and merged, then 4 of them have to rebase, but their tests are already running and have been wasted now. So could we sort of take this back?
The improvement would be if something knows that a PR is already being built. So we'll have to do them in serial because we know that they can only be merged in serial. So there's something that has to check whether this has finished, so now I can rebase the next one, and this has finished, but I don't know if it would. I mean, it would improve things if it's automatic. Right now, we just launch a bunch of PRs all at the same time. The first one is merged, and then you manually have to go and check your PRs and rebase them so that they are relaunched, and then it's raised again.
There might be some way in Jenkins to. It'd be a pretty ugly script, to do some kind of like conditional execution of these jobs based on the
because we
result
could save a
of
lot
the last
of
one. I don't know. A lot of builds as well, because for example, if 2 builds are happening simultaneously and one gets merged, then the Yocto build will happen again when it gets rebased.
Yeah.
Funnily enough, when we had just a single device type per test board, that was introducing some type of serialization, because the next PR wasn't complete until that single test board was free. So
problems that get introduced by scaling up, I see. Right, we can continue.
So anyway, I'm thinking, because I see the use case where you want to run the tests, even though you're not really expecting the branch to merge immediately. You just do the change, push it to the PR, and want to see the test results, whether you have seriously broken something or not.
Yeah.
But at the same time, I understand that for this situation, it creates a lot of bloat. And
again, though, if we've got QEMU and we can just scale, we can just run all these jobs in parallel and spawn up the devices on demand, then I guess it doesn't matter as much. You'll still have to rebase if someone else gets merged, but at least you can see what's
I mean,
happening
for
on
me,
your branch.
yeah, for me, the important thing is that you see that your changes have been built on all the different boards and the tests have passed, and then you see, oh, it hasn't merged. What I personally do is every night I go and rebase my PRs because I know that people are not. There are less people working in my night than in my day, but that's okay because I know it's just a matter of retrying and that's it. So I like to see my PRs build and test it, and then it's just a matter of okay, they will get in with a bit of time. I just have to kick them all the time. Now, whether we could do the kicking in an automatic way, that would be nice.
Guys, we need the test to be fast. We don't need to automate kicking. We don't need to build special cases. We just need the thing to go faster so that none of this is a problem, right?
We are building a lot.
Like how much? Like, are we out of Raspberry Pis in the world, or like what's the what is the actual bottleneck?
In the one that we are looking at, the PIC driver, okay, so this is actually rebuilding the kernel. So the differences we see there are because of building different kernel modules. So I expect that there are some that finished very quickly.
I don't agree. We just added the recipe. Nobody's pulling it.
But I think that just the fact that we added.
Okay, let me check.
I see what you mean, but that must be triggering a kernel rebuild because if not, we wouldn't have times like 1 hour and 15 minutes to build.
It doesn't, but okay. But how can we make kernel builds faster, right? You said basically if we touch the kernel, anything about the kernel, we have to rebuild all the modules. Is that the situation that we're in?
Yeah.
Okay.
Well, that's
so we can. Well, no, it's not how it works. We can fix that. Google has fixed that. It's called libabigail, and it can tell you if you've touched the ABI, and therefore if you need to rebuild, right?
I mean,
Da-da-da.
I guess so, but that's not that easy to implement as a feature in Yocto. I mean, you would have to tell the shared state cache.
Let's throw away Yocto.
We could look into it. I'm not saying we cannot look into it.
Committing to throw away, all of this, all of this time. Who cares about Yocto? Like, what's it actually giving us at the end? Like, and I realize what I'm saying is quite severe here, but why? To make it more specific, why is Yocto in charge of building our kernel? Right, Yocto is about composing things, let's say, but like the kernel could be built wherever, right?
Well, yes, we are heading to this modular architecture, but the situation we have now is the packages are all built in Yocto from source, and the kernel modules are very particular. So I haven't looked at the project you mentioned. I don't know how Google is doing it.
It's called lib. I'll tell you what it is. It's called libabigail, right? ABI, Abigail, got it. And Google built it for Android in order to avoid rebuilding kernel modules when they touch the kernel.
Yeah, I mean, it probably works okay, but yeah. So they kind of
know how to code over there.
So the thing is. So yeah, that would need to be integrated with Yocto if you want it with the current system.
Sure. But what I'm actually asking about is, forget Yocto for a second, right? Is there what are the options if we forgot Yocto, right? So okay, let me ask it in the other way. If we wanted to give Yocto a ready-made kernel, could we do that?
Yes.
Right. So can we look at other available systems for building the kernel that are faster?
Yeah, we can investigate that.
You were very quick saying that we can give a ready built kernel to Yocto.
No, I mean there's a short answer and there's a long answer. So the short answer is yes. The long answer is yes. We would need to integrate it in all the bits, but I don't see how that would not be possible.
Well, you would
Like I see a very clear path taking, I don't know,
wait.
Fedora
So
kernel package, and
you would need the kernel binary. You would need to provide the kernel modules into the root file system. You would need to embed the initramfs in that kernel. So how are you building the initramfs?
Yeah.
well, the initramfs is distinct from the kernel. Like the
Well,
initramfs is just a CPIO archive. If you have the kernel
exactly,
and
but
the
I mean,
bits.
but now you are having to touch the architecture of Yocto, because Yocto expects to build from source, and there are mechanisms for all of that to happen. So I'm saying that's not as easy as it sounds. You cannot just build a kernel binary
I'm not saying
separately.
it's easy. I'm saying it's possible.
Well,
Yeah.
yes,
Okay,
everything
but
is possible, but
sure. Okay, I understand the nuance though, that it's not as straightforward, which is why maybe Yocto is not the platform in general that we need. Then we need to go in the other direction. If I understand correctly, Alex, what you're saying is that so long as Yocto is building the image, it's difficult to do things, right? But if we just use Yocto to build, let's say, the user space, then we could integrate it ourselves into something else with a kernel that we want. But the question is, who does the final packaging? Is that the right question?
yeah, I mean the architecture that we have for for splitting the OS in blocks, it contemplates already being able to build different containers with things like the BSPs and the kernels and the user space, and having a separate tool that is then getting these components that are built however we want. We could use something with Yocto, and we could build the kernel separately. And so it doesn't really matter how the different components are built, as long as the components are containers that we can then pull into an image. And that's the vision we're having. So yes, we'll have these different containers that are the blocks of the OS, which are maintained separately and they are tested separately. And then we'll have like a manifest file or some file with instructions that tells Etcher or some other tool, okay, this is how you actually build the image. So we are separating and we are making modular, and in that way we are also giving more control to our customers over these different blocks. The idea, the vision is something we've agreed for some time, and we are slowly working towards it. But these changes are not that easy to implement. We'll
I
get
guess
there.
yeah, but is there a faster way to get there? Like, because it sounds like we're still going to be within the Yocto world, right? Which means that we are going to have to commit to all of this complexity forever or a long time. Do I understand that right?
That depends. It's true that up to now we've been using Yocto, so we might be a bit biased, but I don't know. So for example, things like the Jetson, the vendor has a Yocto BSP for it. Do they have other type of BSPs? Maybe, I haven't looked into it. Now, if the vendor is only providing a Yocto BSP, it's going to be easier for us to use that.
That's an input to the process,
case.
right? That's an input to the process.
That's an input for the process, yeah.
The question is, do we depend on Yocto to do the connections, not do we use Yocto to build some parts?
Exactly. So in that case, it might just be that, okay, for this particular board, because we have a Yocto BSP, the user space is the container that contains the user space is using Yocto to build it. But we still want to build the kernel in a different way, and that's completely fine.
Well, we don't want to be using unique user spaces, right? If we can avoid it.
Yes, but some BSPs have tools like for flashing or whatever that we will want to build and use.
Will we? Yeah, I think there's anyway. This is a long conversation. I'm trying to find
a complex
Alex.
Conversation.
I get it, but I'm trying to find a way in. Right, I'm trying to find a way, like something we can do, without getting into the hairball. And I guess that's what I'm not seeing.
Yeah, I don't. So I I understand
And honestly, this is why I think Yocto is a problem, because everything you want to touch becomes a hairball. So it's not a modular system. Just by definition, sounds like.
Yeah, I mean, I understand the benefits of having a modular system. I don't kind of see the need to enter it through, we need faster build times. I don't see that
Well,
much of a problem. All the
need
benefits
is
that are more
the
than
need
that.
is simple, which is that we need faster build times. And whenever I ask about the build times, the Y word comes up. So like
Yes, but I'm not. But are you convinced that something else will build it faster? So if we go to a modular system and we have to build all these components separately, and then we have to create the images, I mean, we are assuming that's going to be faster.
No. What I'm assuming is that what we want to do is minimize the rebuild, right? The build time is the build time. That's probably not going to change, or maybe it could even be worse. Maybe Yocto is optimized. I get that. What I don't get is the amount of rebuild that we're doing, given what the changes that we're making. That's the part that doesn't make any sense to me.
So yeah, so we have to understand that it doesn't really matter what we use. If we rebuild the same amount of packages, the build time is going to be the same. Now, right. So the thing is, why are we rebuilding so many things for these specific changes?
Mm-hmm.
I don't have an answer, but I think before jumping to conclusions, we would actually have to look into it. And
right. But this is what came out of the first release party, right? Which we already knew, and we learned it again, and we're learning it again now, and probably at the next one we're going to have the same conversation.
What we know here, for example, is that this PR that is adding an out-of-tree kernel driver is retriggering a kernel build. And when that happens, we build the kernel plus all the modules, and in some of these boards, we have a lot of modules to build, and that takes time. Now, there's two things. We don't always touch the kernel. That's pretty rare. So I'm saying, this is one case. There might be things we can do to improve this, but we have to take into consideration that if we go to a 1-year project just to improve the build time when we do a PR that touches the kernel, I think it's just not worth it. There's no feature out of it apart from, okay, now instead of building for 1 hour 20, I'm building for 40 minutes. So I don't know, it's just examples. And the problem is that because each PR is going to touch
what I'm saying is we need to improve our build times by an order of magnitude, right? 1 hour 20 is 80 minutes. We want less than 8 for this kind of change, right? And by the way, you said out of tree kernel module, so we added a module. Adding a module should not trigger rebuild of all the other modules. Like, the assumption is that the other modules are touching the module that we're changing, which if I'm guessing, it's highly unlikely, right?
Yeah, I don't understand. So what happened, obviously, is that the shared state cache for the kernel was invalidated. And when you rebuild the kernel, you rebuild all modules. Now, why was the shared state cache for the kernel invalidated just because we added an out-of-tree driver recipe? I don't know.
Okay, let me ask a different question. So this is a piece of data that's entered our collective consciousness, right? That this just happened, which, by your judgment, it shouldn't have, right?
Mm-hmm. Yeah.
Do we have a feedback loop somewhere that makes us, because the release parties are so great because of exactly this feature, that we all get to sit around and look at what's happening, and without exception, and I mean without exception, every single time we notice that things are happening that should not be happening, right? So it's almost like the feature is an excuse, and what's actually happening is a process review. But the question I have, I can accept everything we've said so far, right? And Yocto is the best thing ever, and everything. I know you're not saying that. But what I don't like is that there is no process by which we review our builds for what they were and how long they took, and does it make sense to us that they took that long, right?
Yes.
Because without that, then build times were bloat. And then what really, really worries me, right? Here's the part that kills me. When build times bloat, we spend time building mitigations, like doing every time the thing, or every night like a rebase, or disabling tests, or all sorts of things, right? And people are less likely to add improvements, or they like to stage things, which means that the improvements that go to customers as fast. Everything, right? All of the coping strategies. It's scar tissue. I think of it as scar tissue, right? You have a problem and you can't fix the problem, so you're creating additional like smaller problems, hopefully around it, to sort of reduce the pain. But those problems themselves have cost. So I'd much rather be spending that mitigation time on the problem rather than on mitigation, which has other side effects too. But it's better than nothing. Is probably the thought process. So how can we build the situation? Have a situation where we look at our build times with a feedback loop that we can fix things as they occur,
So first thing is that we need to change the mindset about the importance of the task itself. So I know that I'm working on a feature, and I build locally, things work, and then I push my PR. It takes 2 hours to build. I don't even look at it. For me, my feature is the important thing. My feature, my testing, my test. How long it takes to build, not important. You're saying it should be important. So we have to change the mind, and we have to think, okay, if I actually have to go and look at the build times, see if they make sense, and if they don't make sense, I have to stop what I'm doing and go deep into this, look into why this is happening, find out the root cause, and then fix it, which means interrupt the project you are working on. You have to context switch, you have to maybe spend 2, 3, 4 days, whatever it takes, and look into that. Or you have to create an issue into some place that says, oh, this took too long with this particular PR, so you might only reproduce it if you are doing a PR that has already been merged. So yeah, you either look at it at the moment in time, or then you might not have the tools to reproduce it again.
Okay,
with
here's
the same PRs.
Yeah, here's a suggestion I'm making. If we set for ourselves a rule, we don't have to do this, by the way, but think of it as a package that would definitely fix or halve our build times within, I don't know, a month or two. It will probably do more than that, but just as a baseline. If the operating system team, and by that I mean everybody who touches the OS, from the engine to the supervisor to the device type support, the bigger OS team, met once a week to see what and had it like a top 10 table with you, right, of the slowest PRs, right? And you went from the top to the bottom, like which one was the slowest, why does it make sense, second, whatever, until you find one thing you can improve in 1 day. You find a quick thing that can be improved. And by the next week, you review that you have indeed done that, and you look at the next top 10, right? I think if you committed to that feedback loop, in a month or two, you would have drastically reduced the average of the top 10 worst build times that you would be seeing. If you take that top 10 and average it, and that's your metric, I think in a month you will have improved things by a lot.
Okay, no, I see what you say. So okay, for example, we are now running this OS testing project, so we could add a milestone to that, to gather the data first, and then to look into the differences. So I'm curious also as to why the different device types take a lot of different build times. They shouldn't be so different. So I mean, I'm sure we haven't ever looked into comparing the build times even. So we should find the data. We should look into the data, and if it's important, we can do it as part of the projects we are working on. As I said, we just never considered it to take
sure
priority over other things.
Sure. Well, here's the thing, right? Like, why are we working on the testing project? We're working on the testing project. The assumption is that we want to reduce the time it takes from idea to reality, right? The builds are really part of that, of what it takes to go from idea to reality. So, in my mind, it's the same. It's the same bucket, because again, it's a recursive improvement, right? If you can build faster, you can improve the OS faster, which means you can fix things, including build times, and test quality faster. That's why I'm saying it might be worth it. But again, the way I described it is about finding at least one, maybe more, but at least one fix per week that can be done within the week, right, by somebody who will be assigned at the meeting. And then we can even discuss it at the all hands if you want, but definitely in that the next week in that review, we can say, okay, if we didn't accomplish that, then we need to either change who's working on it or whatever. But that would be a failure if we didn't have that improvement done, and probably there should be some pushback mechanism, like having 2 to do next week or 3 or whatever, until we reach at least 1 improvement per week. Yeah, but there's a lot of detail in what I said, and it doesn't really take that much time. The conversation itself could be a half hour, right? At least, maybe more, but maybe that bleeds over to architecture. But the important point is not to find something to do that is long, right? That is a big project. It's like, oh, we got to refactor this, or we got to like deeply review X or whatever, right? It has to be an improvement that we can do, within the week. Ideally, it should take like a day, max 2, for somebody to do. But that's,
Yeah, I think you're a bit simplifying how long it takes to find out what to do. So in this case, for example, if we know that a build took 15 minutes for the Raspberry Pi 2 and it took an hour for a different one, the first thing we need to do is go into the data, into the logs, and see what are the differences. Are we building different packages? Why is that? And
here's the question I have.
Until that process happens, we won't know what can be done to fix it.
I get it, but we don't have to focus on that problem, right? Are there other problems that we know we can provide real improvement within like an hour, a day of work? That's kind of what I'm saying. Like, if we accept that we are going to have complicated problems to work on, then it's going to go down the memory hole, right? The feedback loop breaks. The question is not how do we fix the biggest problem we can see, but what problem can we see that we have high confidence we can fix in a fairly specific amount of time?
So first we'll have to identify those problems. Like in this session, we saw a couple of them. We saw a PR that has triggered a rebuild of the kernel when it shouldn't have.
Yep.
That's also something that needs to be looked into. But again, until you look into the data, you won't know why that is, and if it can be fixed or if it's normal or whatever. So those are the 2 ones that I've seen quite obvious, like the difference in times in between different boards, and that the PR for the kernel took that long. We will have to go through all the PRs and see why it's taking that long.
So it feels to me like we don't really have the data, and correct me if I'm wrong, but like to me it feels like looking at PR by PR is micro optimization. If we had like week-long log of which builds took significantly longer than the others, I'm pretty sure we would find something that's outstanding, and we could focus on that.
So something we've been speaking in the past is there's a feature of Yocto which captures the change history. So if we would just enable that feature by default, then we would probably go and look to the report and say, so this build that took 15 minutes actually rebuilded these changes in the file system. This build that took 1 hour and 50 did these changes. Why is, and that would give us a clue about why it took much longer to build. That might be a way to
if we wanted to
data.
get that top 10 list, like how would we get it right now? Like what would we have to do to get to the place where we can actually even ask the question of what were the 10 slowest builds this week?
So Jenkins,
I would say query
does
Jenkins
record.
and plot it
Yeah.
somewhere.
Query what?
Query Jenkins for the build times periodically.
There's an
and
API to Jenkins,
somewhere.
so we would have to create an app that queries the API and dumps the information. Yeah.
Couldn't we just have it always report back to GitHub or something, the time it took?
We could.
That we don't
query GitHub, I guess, but
no, yeah, I get that, but it's just like I'm just saying, like I don't really love getting tied down to.
I mean, the truth is Jenkins drops the information after a few days, so having it in GitHub would probably be more persistent.
Yeah, I just don't love being married to Jenkins for stuff, but yeah, I don't know. I guess like having it reported back somehow in a way that we could query. Ideally, but also we could do it by hand. Like, okay, how many PRs do we merge a week?
Not a lot, like 10, 20.
Yeah.
Right.
In a good week. Yeah.
So yeah, so it's not like something that requires automation on day one. You know, you can have a sheet and whatever.
Yeah.
Point being,
we also built for unmerged PRs though.
Okay.
You might
also
want to look at those.
Sure. But again, how many are we talking about? Like, yeah, is it 30? You know, we have 10 people on the team. Everybody can take 3 PRs and find the time they took. You know.
Yeah, but yeah.
Anyway, point being, I think if we ask the question, we will find out. But I also do think it's important to focus on smaller things. Not, I mean, of course, it's micro-optimization, but I think as we focus on smaller things, we're actually going to expose bigger things too, and we're going to get better at figuring them out. Like right now, we don't have observability really. Our problem is not even a problem of fixing the problems. We don't know what the problems are, and we don't have a mechanism to find them. Right. Anyway, sorry. This was a sidetrack, and I appreciate you all humoring me. I'm particularly sort of it kills me. The OS build times are like a pet peeve for me because I know how long they take. I know how much time of your time they take. I know that they do we still build multiple times per PR, by the way, to get to production? If you make a change, do we build multiple times now or once?
No, we built multiple times. So we built Balena, and then we built the device repositories with that version of Balena, and then we built release to staging, and then we built to release to production.
Okay, so the last 3, why do we build all 3 of them separately? Why do we build for staging and separately for production?
Because we do it at different times. So typically
Can't
now,
we just
because
use the
we have
image
So I believe they're versioned differently, which might be a minor thing, but the version string is different in Balena and in the device repo because the device repo has
No. Wait. I'm not asking about the Balena versus device repo, which we should fix also, but I realize that that's harder. I'm asking between on the device repo and on staging and on production. These 3 should be the same.
Yeah. So
right? And not only should it be the same, but if the one we're testing is the one on the device repo, to rebuild afterwards is actually an error, because if something goes wrong, you have an untested build in production.
That's correct. You're right.
Yeah, we just don't have the mechanism and the process to identify. So this build in staging can now be deployed to production.
Can I ask a different question? When we build for a repo, right? Why not just push it immediately as a draft release to Balena Cloud, and then do everything else from there?
No, yeah, that's what we are trying to do. We are looking towards that.
Is there anything in our way for that? Because that would cut like half of our builds, basically.
Well, you remember we spoke on the ARCO last week about the OS versioning. So we have to sort that out first, which we are in the process. So it involves some changes to version board, which I'm working on, and we have an open PR for that, and that is the intention, so that we don't have to deploy to staging. We can just do the draft deploy to production and then just flag it as final.
Would that cut half of our builds? Like, because we don't want to deploy to build separately for the device type and then separately for production, right? We should just build and deploy to production as draft and then test that.
Yes.
Ideally.
Yeah. So the path we are looking to is a PR in Meta. Balena is built and tested. It generates a PR on a device repository, which is then built and deployed as a draft to staging. Or if all the tests are automated, is a final release.
Sure, but I mean, we could do draft and then test and then final, so that we move the testing capability within Balena. But yeah, okay, well, but that sounds big. I mean, we will halve our builds.
Yes, that's part of the OS testing project. We are working towards that.
Okay. Cool. Yeah, and then if we also are doing Camu for Meta Balena, I guess that would be also faster.
That will also speed things up.
Yeah. So then we get to like 40% of current time spent on this, right? And then if we're looking for an order of magnitude, then we're looking for another 3/4. But okay, we've basically done half the. If we've reduced, if you want to do 10x, what you want to do is reduce to 1/3 twice, right? So if these two things you just mentioned reduce our build time to 1/3, then we need another reduction to 1/3, and then we've got a 10x improvement. A bit of a hand wave, I get it, but you see what I mean. Okay, cool guys, thanks. This is super helpful. I hope I didn't completely derail the conversation. But yeah, this is super helpful for me at least.
So who wants to resync back to Secure Boot? Michal,
Oh yeah.
Yeah, we're kind of on top of the hour, so we can do the recap. So today we are building, or we are trying to release the Secure Boot and full disk encryption feature for the generic x86 device type. Since the morning, we're still on the first milestone where we've had a bunch of PRs open to Meta Balena, which is our common base for the operating system. We are slowly getting through them. We've got 3 merged, 1 building, and 1 pending. We have found a bug in one that Alex was working on and probably fixed by now. And we still got some to go through and review on the stream. We have also touched part of testing, how we automate test, how we use test lodge for managing manual test cases. And we have now drifted a bit into the future of the OS team, but that's certainly interesting as well. So that's the status update.
Okay, let's go. Should we finish reviewing the PRs? And then it would just be a matter of building them.
Yeah, do you want to do yours first? Did you finish the changes?
Yeah. So, okay, let me share my screen. You guys seeing my screen?
Yes.
Yeah.
Okay, so the first time we built this, it failed to build for the TS4900, which is based on another version of Yocto Sumo. So I pushed a change to an append file in Sumo, and hopefully that will fix the problem. I'm building locally that. I was building locally until my build computer crashed and I had to reboot it. But I also pushed it to the repo, so it should have built, and I didn't see it failing. And before it failed pretty quickly, so I think that will fix it. So yeah, that's it.
Okay. So back to me, I guess. Let's go back to Balena. So where were we? This one is approved and is building. This one is approved and is in queue. We left this one unopened, unapproved for now. And okay, here's the hook for aborting updates on unsigned systems. So we can cover that one next. So this touches a bit about how our OS updates work. As we mentioned before, our OS updates are distributed as Docker containers, where the root file system is basically Docker image. We have a tool called Hub, host up update, that would take this container, unpack it into the newly updated partition, and run some hooks on top of it to make it compatible and bootable. So for Secure Boot, one of the things we want to avoid is running into a state where, while running an as a secure operating system with Secure Boot enabled, it would allow the user to update to a version of the OS that is not signed. And where this becomes a problem is that the one that checks the signatures very first is the firmware. So if we update to an unsigned version of the OS, the device would get stuck very early, somewhere during or somewhere immediately after initializing BIOS, saying the image I'm trying to boot is unsigned. And there is no way we can do that to avoid that, because none of our code has been executed yet. So we need to make sure that when we are updating, the signatures are in place. So this is a very simple hook that we have for that now. What it does is that it checks a bunch of things, like we are running during an update and not during a rollback. We are running UEFI, we are running in secure boot mode and not in setup mode. And if we're missing the signature on, in this particular case, grab configuration, but as you can see, we have comments that we should extend this and make it actually check that the signature is valid. So if we find that the image is obviously not signed, we just print an error message and abort the update. So the OS would not get updated, but the device would still be operational and remotely manageable.
Something else we were speaking yesterday when reviewing this PR is that we have to make sure that we cannot force grab into a fallback mode where
yes,
it would actually show
disabling
you a shell.
The interactive fallback mode. Yes.
Yeah. So we were thinking that if somebody modified the hub image and would introduce this file, but it would actually pass like a wrong configuration to grab or something by default, it will open a shell in grab and then all bets are off. So we had to make sure that we don't have that hole.
Yes, it's not a part of this PR. I've added it as a task to the party, but
Okay.
didn't do anything. I didn't try it.
Yeah,
So
I
do you
think
want?
we need to be sure that we are safe in that. I don't know how easy it is. I mean, it's not like changing a bit of code, and it's something that we have to make sure we do properly.
Mhm. Yeah, we need to try that. I think I said yesterday I would be surprised if it was not possible, but we need to definitely try that and be sure it works. So do you want to note that it should be a part of this PR, or do you want to move on?
No, I don't think it really has to do with this PR. I think let's open an issue.
Okay.
And we need to look at it tomorrow, maybe.
Mhm.
Yeah, we might have to look at the grub source code to make sure under what conditions it falls back to the shell.
Yeah, I remember looking at it. There's a list of outputs that it would show the console on, and I think you either have to leave the list empty or something like that. It would never output anything. Yeah, but we can have a look at it. Okay, that's it.
Yeah, I think you can self-certify this. I mean, we did review it yesterday.
Why did I put it as draft? Oh, I think it's okay. Where is it? Here. No, here somewhere, right? What am I doing? Oh, here. It's very unusual to see it zoomed in. I'm completely lost in the web page. Let's see how we're doing here. No, it's not the one. So a lot of stuff going on. Which one was building? I think this one. So it's still not finished. Nope. Do you know whether the workers are tagged in a certain way? That's not all of them run all the jobs.
No, I think they are grouped. There's a Yocto group, and all the OS jobs are scheduled on that group.
I
And
see.
then
Okay.
it will just get an empty, so an idle worker.
Yeah, okay. That explains some things. Yeah, thank you. So I'm gonna rebase it yet. Next one. Over here, next is unlocking. So this is the thing that actually talks to the TPM and performs the unlocking during boot. What it does, it mounts the EFI partition, asks the TPM to decrypt the password, and then tries to unlock the Lux partitions. And there's a comment from myself from yesterday, which I have not addressed yet, so I'm probably gonna do that now. That it should never prompt password either. So that should be trivial to remove.
We just wanted to remove those lines, yeah.
Yes. Other than that, it's just.
I can work on that if you want.
Yeah. Okay. Go for it. So that's still in progress a bit. So then there's kernel. We have not seen this one yesterday. So what I did, I've added dependencies on curl to call the signing. I've added a group for configuring the encryption. These are the two necessary options to enable Lux and the default XTS crypto algorithm. So let's do here. Yes, it appends the certificate for third-party modules, and it signs the kernel.
Yeah.
And deploys it if we sign.
So we could again use the signing class we spoke about here.
Yes, we have an issue for that. Yeah, other than that,
it's fine. I mean, we can.
Everything else is in the device repo.
Yeah, we can self-certify and we can address the class in the next days.
Mm-hmm. And so the last one is the longest one that I kept for the end. It's Flasher. So, yes. So we have some helper functions that we're going to describe as we need them. And here's where it begins. So the old approach was to just DD the whole image to the internal media. But with encryption, we have to do that partition by partition because we need some of the partitions encrypted and some of them not. So if we are, okay, I'll jump to if not encrypted to see what has changed. So if not encrypted is here, we start a progress counter immediately and start DDing with progress. So DD with progress is just a helper that wraps the old code that was here because I needed to call it in multiple places. Where was it? 0, yeah.
At the top.
Okay,
yeah.
here's the first half, and the loop is here. So that's just factored out into a function. There's no functional changes, hopefully. And so now if we encrypt, so the first thing we do, we check whether we have a TPM available. If we do, we ask the TPM to generate the passphrase. We ask the TPM to allocate a slot for the private key for us and generate the private key or a key pair. We ask the TPM to persist the key pair so that we don't lose it on reboot. And then we ask it to encrypt it, the passwords we're going to use. Okay, we clean up what we don't need. We attach the balenaOS image that we're going to flash to a loop device and scan for partitions. And yes, we start the percentage and we start flashing partition by partition. So there's some things that I did not address yet. So if you're gonna work on the previous, I'll probably fix this one. So we flash the boot partition as this because we want to keep that. Yes, we should not blindly flash 41 megs. We should detect how big it is.
Because the size of the boot partition is actually a variable on the class that creates the image.
Yeah, so that's not difficult to do. It's just
not too much.
Change. Okay. So then we have to repartition the new drive. So what we do is we relabel the original boot partition as EFI. We identify the partitions in the loop device. So we look for them by labels and translate them to indexes. And from that, we identify the size of each partition. So actually, we have the boot partition size here. We could just do it up. We look for the first allocated block of all these partitions so that we know where to start partitioning. Then we remove all we don't need. We calculate the new size together with a 2 meg extra space for the looks headers and create the new partitions. So this thing we discussed yesterday, that there is a workaround that I added for preloaded devices because we operate on megabytes here, and preload resizes the partitions to the exact size it needs to fit the image. So if it's not aligned to megabytes, the resulting file system would actually be 1 block shorter. But we've had the idea to start a discussion with the CLI guys whether preload should actually align to something like 4 megs or 4 kilos or something like that.
Yeah, so when we build the images in Yocto, in the class, we make sure that every partition is aligned. And when we preload, we are breaking that alignment, which we probably shouldn't be, because it's faster to access an aligned partition.
Yeah, so I'll create an issue for that.
Yeah, there's also the thing that we are now finishing up with a different partitioning scheme for this device type. So it's like if we've added a special case for this device type, and I think that if we had a broader discussion, maybe we would have came up with something common, like different way to partition, because we are also having the same problem when adding MBR and GPT partition tables. So we also think that we are going to need another partition for MBR. And I just don't like just these special cases in partitioning for a specific device type. It doesn't sound very good.
I'll create an issue for that as well.
So in the longer vision, we've been speaking before that we would have some other thing that is not Yocto that is actually doing the image. And that process of creating the image will have like some instructions or some contract that defines partition sizes and number of partitions, and that's exactly what we're speaking about here. So this to me feels like something that we know how it's going to be fixed in the future, but we just need to do it this way for the time being.
Okay, this one, and what was the other one? The partition. Figure out way
Well,
for describing the partitions.
Well, I don't think that's an issue. I think that's
it's a
part of
brainstorm
the.
topic.
Yeah,
Or part
it's
of the
part. Well, we spoke
Balena
about
OS
it
3.
before. Yeah, yeah.
Okay. Do we have it in the roadmap, right?
Mm-hmm. Yeah.
Okay. So we're not gonna forget that. Good. So where were we? So we created all new partitions with the extra headroom for the encryption headers. And now partition by partition, we're gonna flash them. Okay, the same issue as in the unlocker, that it could prompt for a passphrase. So I'm gonna ditch that. Yeah, it encrypts the volume, it unlocks the volume, and when it's unlocked, it DDs the data into it, with the exception of the new boot partition, which we repopulate somewhere below. So when all the partitions are done, we detach the loop device, and that's it. So if we're encrypting and the EFI partition is split, we need to mount it, obviously. And when it's mounted, we do the split. Everything that's under /EFI we keep in the EFI partition, and everything else we move to the newly encrypted boot partition. So we also move the TPM metadata to the EFI partition, and we move the kernel that will become second stage bootloader to the EFI partition as well. And we fix the bootloader path because it now lies under /EFI, obviously. Okay, we populate the signature if it's available, and then just clean up, unmount, and close the LUKS devices. That's it.
Yeah.
So
any
other comments, except for the ones that are already mentioned?
Not from me. Just, I mean, it's the second time we look through it, self-certify.
No, I'll fix it and then self-certify.
Oh yeah, you need to remove, yeah.
I need to remove some stuff and detect the boot partition size. So yeah, I think I'm gonna jump on that. Have we lost Mark?
So just to remind me, what was the other
I'm
PR
here.
You're here.
I was supposed to work on?
Unlock something from the entity. Okay. Add a script for unlocking Lux volumes. There's just removing the if that handles prompting for password, which is never triggered.
Cool. Yeah, I get it. Okay.
So Mark, it looks like we're gonna do some focused work for a bit. So
Okay.
if you have something to talk about.
Sure. Alex, what would you like to talk about?
I'd like to talk about why these guys are having to present when, normally, there's usually people here who can help them out with content. But yeah, is there somebody here who is supposed to be holding the flow? Because I'm seeing Alex doing both, and it's kind of sad.
Yeah, I was trying to help, but when it gets very technical, so it's...
Cool. Well, back to you then.
Okay. Some of the topics that I had here to mention, maybe it's a great idea as well to mention that you are watching the 7th release party that shows how we work at Balena. We are a fully remote company, and yeah, we are hiring. So maybe we can mention some of the open positions. Let me share my screen. In a sec. Not disturb. I'm going to share this. All right. So Balena, we are hiring. I'm going to share this link through the chat in a second. But we have several positions open. Plus, we have, since 5 years ago, says here, design your own role. So if you don't fit on any of these positions, that's not a problem. Just go to design your own role and feel free to let us know how you can help Balena or how you think Balena can help you. We are searching hardware engineers, so probably to help to define the new Balena Fin and to help the Balena Fin team to succeed on hardware. We are searching a software engineer for product development platform for the product OS team. So yeah, if you are a software engineer, I think on Node.js, PostgreSQL, so you're gonna work with the Jellyfish team, and yeah, you will have fun helping all the Balena developers to succeed doing what they do, and as well, we are a support-driven company, so we are basically using massively this tool. So it's a really interesting position if you're a software engineer. We are searching as well a data lead or a data scientist. So if you're a data scientist and you would like to work on a remote position and you like what you are seeing, so feel free to apply here. What else do we have? So we are looking for 2 site reliability engineers, SREs, in European time zone and in America time zone. Sorry. So if you are a site reliability engineer, feel free to apply here. And if your position it's not actually described here, that's not a problem because we have tons of people at Balena that just apply at Balena with the design your own role position. So yeah, go here and just apply for this job. Explain how you can help at Balena, how you would love to help IoT companies to succeed with Balena technology, and we will take this into account. What else we would like to mention? It's something that I would like to mention more. Yeah, it's the Balena Hub challenge. Yeah, let me share my screen again, sorry. All right, so for new people that it's here that never saw any other release parties, we have developed Balena Hub on previous release parties. And Balena Hub, you have to imagine that as an IoT or edge application marketplace, kind of, where you can, as a developer, introduce your projects or your applications here and enable people develop or inspire other developers to join your fleet of devices and use your projects and applications and technologies on their devices in the edge, or just submit your projects through Balena Cloud, or submit your blogs. So let's get into them in a second. But before that, I would like to mention that we are running a Balena Hub challenge. So if you have ideas for IoT edge applications that can be submitted on Balena Hub, feel free to apply. You have until 30th of November, 12 p.m. 12 a.m. UTC to submit your project, and you can get prizes like cash. You can get cash, but something that it's for me super cool is that you can be featured on Balena Etcher. So probably most of you know Balena Etcher. It's a software for flashing SD cards and USB drives. And see, if you have been using it, you have seen that sometimes we feature some projects. Your project can be there, and millions of people can actually get inspired by your project and join your fleet or use your technology, the UFDs. And then, of course, you can get swag and other things. Let me mention some of my favorite applications, but before that, I would like to share with you for the Balena Etcher, the Etcher feature projects. For example, this Balena Raspberry Pi Play application that is an open fleet. So there are more than 1,000 active devices in the last 28 days. That means that that being on Balena Etcher feature project, can inspire a lot of people, and a lot of people can use your technology. When you submit something on Balena Hub, this can be a fleet. That means that you create a fleet on Balena Cloud, and you are the fleet owner. So anyone can join your fleet, the device. So if I have a device, I can join your fleet. But the software is managed by the fleet owner. Then there are the projects, which are applications running on Balena Cloud. So if I want to install, for example, this Helium data hotspot, for example, I just click fork this fleet. I need to create a Balena Cloud account and just add my devices into my fleet. And finally, we have blogs. And blogs are pieces of services or containers that enable you with new features, so you don't need to reinvent the wheel and make things from scratch. So this is having a lot of success lately, because a lot of developers discover that having a blog on Balena Hub accelerate a lot the development of their projects on Balena. So get here, check if what you are trying to develop it's already done, and get the benefit of using the blogs from Balena Hub. So you can actually speed up the development of your projects of Balena. And yeah, some of my favorite fleets, not sure. One fleet by one of the developers from our community is the Ribbit network. It's a CO2 sensor, so it's a citizen science project that we are super excited to have here. It's you need to get some of the instructions on the website. Just get a CO2 sensor, and with a Raspberry Pi and SD card, you can just join the fleet of the Ribbit network. Or, for example, you can have a Balena Minecraft server. Or another one that I have been collaborating, it's Bird Watcher, for example. You can build a bird feeder.
Cool. Thanks, Mark. I think we got the point. It sounds like you're gonna just continue the commercial. So that's not quite a release party. Okay, so folks, where are we? Do we want to talk about anything else? Do we have other stuff to talk about? Do you want to do some of the work that you're doing live, maybe?
I finished my work already, so mine is pushed. We did some live work before, so I was doing some other fixes. But yeah, if Michal, I don't know if you're still working on your stuff.
Do we maybe before we even get to that, do we as a foresight, do we have a sense that we will get somewhere today? Like, what's the prediction here?
So the original goal was to get at least something to staging that we could test. But honestly, with how slow the builds are going, I don't see that happening. So I think we're going to try to merge as many PRs as possible and finish it tomorrow or early next week.
Okay.
Yeah, I think that, I mean, it was probably miscalculated, because if we had 9 PRs, even if, I mean, they have to be merged sequentially, because each time you merge one, you have to rebase the next one. Even if it takes half an hour to build, we spend more than 5 hours building.
So I tried getting some of them merged prior to the thing, but it didn't really work out. So
we have a question from Christian in the chat. He's asking if the documentation for the Secure Boot and Disk Encryption is already available anywhere, or what's the plan?
It is not, unfortunately. It was one of the tasks for the party, but given how we have slipped,
I think what we're gonna do is do a part 2 next week. I think that's the only way to make sure this happens, guys.
Yeah,
that's good.
Sounds good.
Yeah, but I actually try to release something. Because I get it, but I also wanna I don't know, maybe after that do some kind of a hack week or something to improve this build speeds, because every release party that touches the OS has the same problem, and I don't think it's a release party problem really. I think it's a operating system team problem. Not that you are the problem, but that you have the problem. Be precise. And I think you don't. I think you're either suffering this in quiet, or you don't even realize how bad it is.
So let me give you my theory.
Yeah. Please go ahead.
I don't think we realize how bad it is, because it gives you a great chance of multitasking. Like, we always work on multiple things in parallel. So you do one small thing, let it build, and jump to another small thing. And this way you have like 5 small things running in parallel. So the immediate hit where you push the feature and have to wait for the very long time never really hits you, unless you're forced to do something like this, where you have to actually merge a lot of PRs sequentially.
Yeah, but I mean, do we have in other parts of the stack auto rebase?
That's a good question. How does it work for the rest of the projects?
I'm under the impression we
They
do,
must
but I'm
have the
not
same.
sure.
Yeah,
I mean,
don't know.
one thing we've
I've always
envisioned,
had to rebase.
we don't have it, but we've envisioned it, is essentially, let's say you leave for the night and there's 10 PRs ready, right? That there would be a system that would do basically kind of 1 and then 2 conditionally rebased on 1 and 3 conditionally rebased on 2 and 4 conditionally rebased on, like, so you basically, if everything works, or to the degree that everything works, when you wake up, you can do merge, 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 and it's all ready to go. It might fail, but then it might not, right? And then you've got a bunch of progress ready to go. Or if it does fail, I guess it could then skip that one and try to rebase another one on top. Like, basically, you see what I mean? Like, try to go as far as it can with the PRs it's got available with rebase and merge, or well, conditional merge, right? Not actually merge, but assuming it gets merged, then rebase something else on top of it and try to test it so it's ready.
How did it work on the other parties we made when there were several PRs to merge at once?
They're just a lot faster. And they're more parallel, right? Because they're different components. So it's not like this one big thing that's waiting for everybody. Like we don't have a 1 PR at a time. So it's both faster and more parallel, I guess. And this is actually, Alex, another important thing here that I'm realizing now, which is that if we had a modular system, we could merge all the other things and then do the big one right at the end, rather than freezing everybody for everything.
Yeah.
Yeah.
So do we have a project in the company that has a big team of people working simultaneously? So if we have to make like a change, Jellyfish, so they probably suffer the same problem then.
They've spent a lot of time optimizing build times and modularizing, which is what I'm advocating for here.
Okay, so they are not all having to commit to the same component. That doesn't happen often.
No, and we also are not committing the same component. We're committing the same like environment, right? Full product. It's
the same repository basically. So the problem we're having is because we are committing to the same repository, while you're saying that on a different project they probably have components that live on different repos.
No, but you do. The way you're saying it, it sounds like it's an accident. Like we used to be one big repo, and we realized that was very, very slow, so we broke it up. Yeah, we fixed it. Like we didn't, we weren't happy with the way it was working, and we said, well, let's. So here's another question: could we modularize Balena? Should we?
We definitely
splitting recipes by some key and having the basically.
Well, we've talked in the past
what
about
is a Balena layer? Have it like multiple layers, but not colliding in any point.
Yeah.
I don't have enough knowledge to say.
No. Yeah, I mean it's doable. It's possible, and we've spoken about the vision for the OS is to do exactly that, to have a repository for kind of BSP that builds like a BSP container, a repository for
like the long-term goal
system service.
Perfectly.
And yeah, so I mean, what would that have helped us today if we had that? And also, how complicated is it to do? Because I'm aware that there is some internal separation in that repo, right? Like I think there's like a networking element that is somewhat more separate, and there's maybe some other things. I'm not sure.
Actually, good point. We've got the recipes core, recipes BSP, recipes kernel. If you just slice it by this, make sure they don't collide, like one repo per recipe type.
Would that have helped us today to have a faster velocity, higher velocity?
At least a bit, for sure.
Yeah, that's interesting.
So
Very
yeah, the problem of having to do it sequentially is because they all have to go to the same repository. If we split the metadata into different repos, it would have helped.
And only put it together like in the device repo.
Yeah, but also, if you just do it for the sake of build times, I think we are going to get there because we want to find logical blocks to split it. So we want a BSP repo, we want a user space repo. So it's not just like, oh, let's do each single folder in one repository. Just it's a bit arbitrary. It helps, but I think you need to keep some type of structure at a logical level.
No, I mean, I always felt like the recipes, something directories are somehow artificially like split.
Yeah.
So that's why I suggested like it's split in some way. I don't know why, grep is in BSP and kernel is separate. They should be together in my world, but
yeah, arbitrary.
It's one way of splitting it. That's probably what I'm saying.
I guess is there a better way? Like, shouldn't we fix that anyway? I mean, if there's some structure there and it's not a good structure, we should improve it, right? And like regardless. Otherwise, why do we have a structure? Just throw it all in the
It's
same
like
folder.
we inherit. We inherit the structure.
Oh, I know we inherited it, but at this point, it's our responsibility. Like there's at some point, it's like the new government, comes in.
It's not something that
we
copied it.
I see.
We have a layer below us that has that structure, so we just inherit it.
What's that layer below us?
Pokey.
But Pokey's separation is not very sensible.
It's arbitrary in the way we are describing.
Interesting. Yeah. Oh, interesting. Sorry, I thought you meant, yeah, okay, got it. I thought you meant inherited it as in from the previous people who were making balenaOS.
No, yeah. It is the structure of the Yocto project. It's the way it is.
Yeah.
So, Michal, you're going to share so that we can.
Yeah, I'm done in the meantime as well. So
you want to share? Should I share your screen, Michal?
There's nothing to share at this moment. We can go through or have a look at the Jenkins job, if you wish.
I think that if we know the status of the PRs, we are not going to get much further. We're just going to make time until they emerge. Really, it's 5 p.m. So we've been here. The time we should. We made it where we made it. We acknowledge we are going to have stage 2 of the party next week.
Yep. Yeah,
we
I think so.
should maybe just leave
but
it here.
Another thing for the release party is to not rely on, there are US members of the OS team, right? There's Kyle, there's oh man, I'm blocking now. But he's here. My neighbor, Joseph. God damn it. Joseph. Like we could have structured it so that we can and maybe we should for next time, that we can give over the torch, so that the relay, so that you don't have to stay late, but we also don't have to just stop at 8 hours.
Yeah, I think one of the things is that because this specific feature has been the baby that Michal has been working on for a whole year, he has taken like his responsibility to move it forward, and we have 2 days of preparation time also, so it's not much.
Yeah, I mean, we did our best. Alex was great helping.
Yeah.
Yeah.
No, this is great, and I mean the release parties are really intended to show what can be done and what is the problem often. So I think we learned a lot, and yeah, next Thursday, part 2.
Okay,
All right then.
we'll do better. Promise.
I just feel sad for you guys, like that the build system is so like slow and wasteful that you can't get your job done quickly. Like I dream of a world where, you know, development is fun, you know, like you do it locally. Or here's another question, like why don't we accept your local build as a build? If we accept your code, why not just upload your local build and just we accept that that's a valid build? You know? If you
I would
it,
say
it's there. Like, you know, why not?
reproducibility. So,
but we don't. We throw it away.
Oh,
we throw it away.
No, but the conversation is okay. So if we then have a deep obscure problem in that build, can we reproduce it somewhere else than that specific computer where it was built? That's typically why you build OSs on build servers that are a controlled environment that you know that builds are reproducible.
well, you could at least use your build for running the tests on it.
Yeah.
Like have testbot accept it, and then throw it away.
Well, you can run your tests locally with a local testbot.
Yeah, that's true. Anyway, yeah.
Let's wrap up the session then. Now that it's
like we're gonna wrap up.
Cool.
Yes.
Part 2 next
We've learned
Thursday.
a bunch
Thanks,
of
everybody.
things, and yeah, thanks everybody. Thanks everybody for joining us.
Nice
Bye,
seeing
guys.
you, everyone.
And
Bye.
See you.
Bye, Todori.
Bye.
Thank you for joining. And yeah, see you next week to finish with the secure boot and full disk encryption of x86 64-bit devices with TPM 2.0 secure elements.
Bye, guys.
Bye bye.
See you.
Have a good day. Bye.